There exists a particular stillness that settles over the water when the work has stopped for the day. On certain Pacific evenings in the year 1943, men would finish their shifts in the shipyards of Portsmouth, New Hampshire, and Mare Island, California, stepping back from steel hulls that were still warm from the welders' torches, still humming with the recent violence of construction. They would walk home through lengthening shadows, their hands stained with oil and metal dust, their ears still ringing slightly from the day's noise, leaving behind them the skeleton of something that would soon be more substantial than most things that moved across the ocean. Picture, if you will, a moonlit evening at one of these yards. The water laps quietly against the hulls of completed submarines, tied at their moorings. The steel catches what little light falls from above, and you can see the faint grid of welds running along the pressure hull like a geography of repair and intention. These boats are rounded, deliberate shapes, nothing like the destroyers or cruisers nearby. A submarine at rest looks almost organic, almost sleeping. The hum you hear is not dramatic. It is the low murmur of generators keeping systems warm, of ballast tanks settling, of steel cooling in the night air. Perhaps there is the distant sound of a watch bell from the water, or the soft creak of a mooring line. The smell is metallic, salt-tinged, mixed with diesel and the ghost of welding flux. This sensory world, this small, specific corner of wartime American industry, is where we begin, not with grand strategy or desperate battles, but with the simple fact of one boat tied to a dock, waiting. Because in the months when these submarines were being built, there were men making decisions in places far away, in offices and strategy rooms, who imagined a particular future that would require vessels like these. They imagined an invasion. They imagined thousands of soldiers, landing craft, bombardment. They imagined that American forces would need to bring the war to the Japanese home islands themselves, and that submarines, among many other things, would be part of that machinery. The Tench-Class Submarine was engineered, refined, and built with that future in mind. But the future changed, and we are left with the peculiar echo of machines, designed for a world that never quite arrived. Before we go deeper into the stories of these boats, the patrols they took, the men who crewed them, the missions they undertook, and sometimes never completed, I want to invite you to stay with us for the full history. If you enjoy stories of engineering, of the quiet ingenuity of naval design, and of the subtle ways that war and preparation shape the machines we build, you'll want to subscribe to Fall Asleep Too for the complete telling of the Tench-Class Submarine, built for an invasion that never came. There are many chapters ahead, gentle and unhurried as this one, following these boats from their conception, through their war service and far beyond, into the Cold War and into the museums where some of them rest today. But for now, let us remain with this dock, this evening, this particular quality of silence. The year was 1943. The Pacific War had been running for more than a year and a half. The American submarine force had already proven itself essential, sinking more tonnage of Japanese merchant and military shipping than any other weapon system in the Allied arsenal. And yet, there was a hunger among the men who commanded submarines, a sense that the tools they had in hand were not quite adequate for what was coming. The Gato-class submarines, which had borne the bulk of the underwater war so far, were good boats. They were reliable. They could dive deep, stay submerged for days, and carry a full complement of torpedoes, but they had limits. Their operating depth was constrained. Their endurance, while impressive, could be longer. Their machinery was not as quiet as designers might wish, and there was always the question, what if we needed to go deeper? What if we needed to stay out longer? What if the enemy developed tactics against us that required us to adapt further? This is a question that engineers love to contemplate in wartime. It is a question that keeps them up at night, even as so many others are trying to sleep. What could be improved? What could be refined? What could be done differently, better? more intelligently. In the design offices, the sketches began to appear, first at the naval yards, then at Electric Boat down in Connecticut, little marks on blueprints, a thicker section of hull, a rearrangement of internal tanks, different positioning of machinery to reduce noise. These were not revolutionary changes, you understand. There was no moment of sudden inspiration, no single genius shouting Eureka in a laboratory. Rather, it was the quiet accumulation of what they had learned. Every submarine that returned from patrol taught them something. Every torpedo that performed differently than expected. Every depth charge that came closer than anticipated. Every crew report about noise or vibration or difficulty. All of it was fed back into the design. The Tench-Class Submarine was, in a very real sense, the answer to questions posed by the men who had sailed the Gato and Balao classes and lived to return. Picture now the drawing tables themselves, lit by the warm glow of desk lamps, the architects and engineers bent over their work. This is where steel becomes intention. This is where specifications are born. The papers before them contain lines and numbers that seem almost abstract until they are realized in metal. A thickness here, a weld pattern there, a slightly different arrangement of cooling water pipes. These men are not heroes in the conventional sense. They will not fire weapons or see combat, but they are engaged in a form of creation that matters profoundly. They are trying to imagine a boat that does not yet exist, trying to anticipate problems they hope will never occur, trying to build something strong and capable and enduring. On some of these evenings, the engineers would have stopped their work and looked out the window toward the water. They might have seen a completed submarine being tested, moving slowly through a channel, its conning tower cutting the water like a sharp thought. They might have heard the sound of its diesel engines, or caught a glimpse of a training crew on deck. This is what their drawings become. This is the moment when mathematics and intention become a thing that can float, that can move, that can carry men beneath the surface of the sea. The submarine, at its heart, is one of the most intimate war machines ever conceived. It is not sprawling like a battleship. It is not distributed like an aircraft carrier. It is narrow and dense and closed in upon itself. It is designed to be, necessarily, claustrophobic. Every inch is used. Every system is stacked and layered with intention. To work in a submarine yard, to help build these boats, is to participate in a peculiar craft. The welders would work in sections, joining what would become a pressure hull, the inner wall of steel that must hold together under crushing pressure. The riveters would follow, or the men with welding torches would come back and forth, building up the structure. There was a terrible noise in these yards, a percussion of construction that seems almost violent when you contemplate it now, knowing that these sounds were shaping instruments of war and survival. Yet there is something almost meditative in it too, when you imagine it from a distance. The repetition, the specific knowledge required, the collaboration between hundreds of workers, each doing their small part in a much larger whole. No single person built a submarine. It was always a collective act. The hull of a Tench-Class submarine, when completed, would be just over 300 feet long. It would displace about 1,900 tons when surfaced, more when submerged. It would carry a crew of 81 men, more than the earlier Gato-class, because the design had been stretched slightly to accommodate additional equipment and supplies. These men would live and work and sleep in spaces so confined that you could stretch your arms in some sections and touch both walls. For weeks at a time, they would not see the sun. They would exist in artificial light, breathing air that was recycled and scrubbed of carbon dioxide, surrounded by the constant low rumble of machinery, the creaking of steel responding to pressure, the occasional groan of the hull as depth changed. Does this sound like a place you would want to be? For many men, the answer was yes. Something about the submarine service called to a particular kind of person. There were volunteers who sought out this life, who wanted to be part of the submarine force. Perhaps it was the novelty. Perhaps it was the pay, which was slightly higher than regular naval service. Perhaps it was a form of courage, a willingness to place oneself in a sealed metal tube and descend into darkness. Most likely, it was some combination of all these things, mixed differently in each man. But we are getting ahead of ourselves. We are still at the dock, the moon is still high, or perhaps it is beginning to descend toward the horizon. The submarine is still tied to its mooring, waiting for its moment. The steel is still humming, still settling, still becoming what it is meant to be. And somewhere in a design office nearby, the last sketches for a new class of boats are being finished, rolled up, prepared to be sent to the yards that will build them. These boats are not yet real. They are not yet steel. They are pure intention, pure hope, pure design. The Tench-Class Submarine was born from a very specific moment in history. It was conceived in the belief that the war would continue for years. It was designed for a future that would require endurance, capability, and the ability to operate in conditions that earlier boats could not handle. It was built for an invasion that seemed, in 1943, utterly inevitable. An invasion of Japan, Operation Downfall, they called it, a vast military operation that would eclipse even the invasion of Europe. And for this operation, the Navy wanted submarines that were better, stronger, deeper diving, longer ranging than anything that had come before. Imagine the weight of that knowledge among the people who built these boats. They did not know, of course, that this invasion would never happen. They did not know that the war would end before most Tench-class submarines ever heard a shot fired in anger. They only knew that they were building something important, something necessary, something that might, in some unknown future moment, be the difference between victory and defeat. So they built. And as they built, they refined. And as they refined, they prepared a fleet of submarines that would, in the event, outlive the war they were designed for. They would persist into the Cold War, into an entirely different kind of conflict, against an entirely different kind of enemy. Some would be scrapped, some would be preserved, some would... You might wonder sometimes why a particular ship came into being at a particular moment in history. The Tench-class submarine wasn't born from sudden inspiration or urgent desperation, but rather from a quieter impulse, the slow accumulation of knowledge, the patient refinement of designs that had already proven themselves in earlier waters. This is the story of how that refinement took shape, not as dramatic breakthrough, but as the steady work of engineers and builders who understood that the next class of boats would need to do what the previous ones could not quite manage. They would need to go deeper, travel farther, stay silent longer, and endure the weight of expectations about a future that nobody could yet see clearly. If you find yourself drawn to these slower, more deliberate histories, the kind that move at the pace of construction rather than combat, that find meaning in the small decisions made at drafting tables and the careful work of riveting and welding, there's an entire archive of Pacific War stories waiting to unfold. Stories of the submarines and the men who served in them, the destroyers and the naval engineers, the supply ships and the radar technicians, all of it told in this same unhurried way, designed to settle into the mind as easily as sleep settles into a rested body. Each story builds its own atmosphere, its own sensory world, the particular sound of a steel hull under pressure, the quality of silence in a radio shack during a tense approach, the texture of daily life in spaces so confined that men learned to move through them as though they were dancing a dance they'd memorized. These are the kinds of details that emerge when you have time to listen, when there's no rush to get to the dramatic moment, because the whole point is to live inside the moment itself, to understand not just what happened, but what it felt like to be present when it happened. The machines of the Pacific War operated within a specific technological moment, a threshold where one kind of naval warfare was giving way to another, where speed and stealth were becoming as important as firepower, where the submarine was no longer merely a weapon, but a strategic instrument that could reshape entire campaigns. And the men who served aboard these boats, they lived in a world of absolute concentration, of routine that was interrupted by moments of genuine terror, of camaraderie born from the certainty that every person on board depended absolutely on every other person doing their job correctly. That combination, the marriage of mechanical complexity and human vulnerability, is what gives these stories their particular depth. The Tench-Class sits at a crossroads in this history. It wasn't the first of its kind, and it wouldn't be the last, but it represented something significant. The moment when the submarine force of the United States Navy reached toward something new, toward capabilities that were being designed with a specific future in mind, a future that would ultimately never arrive in the way the planners imagined. There's a poignancy in that, in machines built for a war that ended before they could fully come into their own, in hulls that were launched expecting to serve for years in the deepest, most dangerous waters on Earth, only to find that history had other plans. The story of how these boats came to exist, of the minds that shaped them and the hands that built them, moves through different registers. There's the technical register of engineering specifications and hull tolerances and metallurgical improvements, but there's also the human register, the sound of a shipyard at full production, the rhythm of work that was itself a kind of war effort even for those on land. And there's the strategic register, the calculations being made by admirals and officers about what the next year or two of war would require. What kind of boats would be necessary if the enemy refused to surrender when expected, if the fighting had to continue inland on beaches and islands all the way to Japan itself. All of these registers, woven together, tell the story of a moment in time when uncertainty and planning collided, when the future was being built in steel and electricity and the accumulated knowledge of decades of submarine development. The Tench-Class emerged from that collision with particular characteristics: deeper diving capabilities, longer endurance, improved habitability in certain ways, and a fundamental strength that came from lessons learned in the boats that came before. But the real story isn't just in those specifications. It's in understanding the weight of the choices, the careful calculations that went into every design decision, and the knowledge that somewhere in the future, men would be trusting their lives to the results of decisions being made right now, in offices and at drawing boards across America. The slow unfolding of this history, from the initial concept through the design phase, through construction, through commissioning and the early patrols, is a journey worth taking in full without rushing toward any particular dramatic conclusion, because the meaning of these machines and the meaning of the men who operated them isn't found in the climactic moments alone. It's distributed throughout the entire experience, through the smaller moments of recognition and choice and commitment that add up to something larger than any single event could contain. And that's what these stories are meant to explore: the texture of history itself, the way that meaning accumulates slowly, the way that understanding deepens when you're willing to move at the pace of actual experience rather than the compressed pace of summary and conclusion. The waters where these boats would eventually operate were vast and deep and often cold. The routines they would establish in those waters were meditative in their way, punctuated by moments of acute awareness and danger. The knowledge required to operate these machines was specialized and deep. The trust between crew members had to be absolute, and all of it, every element, was being prepared for in these early months of 1943 and 1944, when the design was still being refined, when the first hulls were still being laid down, when the future stretched out ahead with possibility and uncertainty mingled together in equal measure. If these are stories that resonate with you, stories that speak to that particular combination of technical precision and human endurance, stories that move at a pace that allows contemplation rather than demanding reaction, then you've found a place where those stories are being told in full. Not in fragments or summaries, but in the kind of detail and depth that these subjects deserve, the kind of unhurried attention that allows the listener to settle deeply into the experience of understanding not just the what, but the how, and the why, and the what it felt like, that animates the entire narrative. The Pacific War had already turned decisively in America's favor by the middle years, and yet beneath the surface, in the shadowed corridors of Naval Command and the quiet rooms where admirals studied maps and loss projections, there persisted a gnawing uncertainty about the machines that would finish the fight. The submarines had proven themselves. They had sunk merchant tonnage, damaged warships, inflicted casualties upon the enemy in ways that surface warfare rarely permitted. And yet, as 1943 gave way to 1944, those who understood the scope of what lay ahead, and there were enough of them in positions to matter, began asking a question that would not rest easy in their minds. Were the submarines they possessed truly adequate for what came next? The Gato-class boats had been the backbone of the fleet, and they served with distinction. 37 of them were built, their sleek hulls becoming symbols of American submarine prowess in the Pacific campaigns. They could dive to depths that few other submarines of the era could match. They had range enough to strike across vast ocean distances, and their crews had learned to use them with devastating effect. The Balao class, newer and slightly larger, had begun to supplement them, bringing marginal improvements in hull strength and operational endurance. But those admirals, those engineers, those captains who spent their days in contemplation of submarine warfare as it might unfold in the months and years ahead, they sensed something incomplete in the picture. The war was not going to end quickly. Japan's home islands still lay unconquered, and the prospect of bringing the entire might of American naval power to bear upon a defended homeland of vast size and determined population seemed to demand something more, something different, something refined from the lessons already learned in blood and salt water. What was it, precisely, that was lacking? It was not a single deficiency, but rather an accumulation of small restraints, operational limits, that had become apparent only through the grinding experience of campaigns already fought. The submarines could reach the enemy's homeland, certainly, but the depth to which they could safely dive was often determined by the thickness of their steel hulls, and there were waters around Japan where the pressure at operational depths pushed the limits of the existing designs. The range available to them was measured in weeks of sustained cruising, but those weeks were finite, carved out of finite fuel reserves and the slow burn of diesel engines pushing through open ocean. What if the war extended further? What if operations required even longer legs, even deeper stays beneath the surface, even more room for the living and the machinery that sustained life in those cramped spaces? And then there was the matter of production itself. Could the shipyards produce enough of the existing classes fast enough to meet the strategic demands that were beginning to crystallize in the minds of fleet commanders who were already thinking ahead to 1945, to 1946, perhaps even beyond? It was a particular kind of strategic anxiety, the sort that military planners rarely voice aloud, but which drives decisions in committees and in private correspondence between officers far removed from the theatres of actual combat. The submarine force had earned respect through its accomplishments, yes, but it was also resource-hungry, requiring scarce industrial capacity, requiring skilled labour, requiring the best materials available in quantities that other services also desperately needed. To justify continued expansion, to justify the construction of new classes of submarines beyond what was already on order or under construction, there needed to be a compelling argument that these new boats would offer something genuinely superior, something that would justify their expense and the opportunity cost of the materials and skilled workers diverted to their construction. Into this uncertain space stepped a question that was perhaps less urgent than practical. Could the existing designs be quietly refined, incrementally improved, without requiring a wholesale redesign? Could the engineers begin to sketch out a submarine that took everything learned from the Gatos and Balos and pushed a little further in every direction? A boat that dove a few hundred feet deeper. A boat whose fuel tanks held a little more diesel. A boat whose welded construction might be stronger than the riveted hulls of earlier generations. A boat whose engine spaces were quieter, whose acoustic signature was diminished, whose hull form was refined through the accumulated small adjustments that only time and experience could suggest. The search for something better was not dramatic. It did not announce itself. There were no headlines, no public announcements of new programs or revolutionary designs. Instead, it was the quiet work of naval engineers in offices in Virginia and Connecticut, men who spent their days poring over hull plans, studying the physical properties of the steels available to them, calculating displacement and buoyancy, and crushing depths with slide rules and careful mathematical precision. They were building upon foundations already laid, making adjustments at the margins. Yet those margins, when properly exploited, could yield significant gains in capability. What began as a thought, a private conversation between officers who understood both what the current submarines could do and what they might yet need to do, gradually became a sketch, then a specification, then something approaching a preliminary design. And somewhere in that process, not with fanfare or ceremony, but simply as an inevitable consequence of thoughtful men asking intelligent questions about the future they could foresee, the first true conception of what would become the Tench-Class Submarine began to take form, still without a name, still without an approved contract, but present nonetheless as an idea gathering strength in the quiet corridors where such things are decided. In the quiet hours of 1943, while Pacific campaigns churned toward their inevitable expansion, something altogether different was taking shape in the drafting rooms of Portsmouth Naval Shipyard in New Hampshire and the sprawling facilities of Electric Boat in Groton, Connecticut. There were no headlines announcing this work, no newsreels following the pencil strokes of men bending over drawing tables beneath the warm glow of desk lamps. What was happening instead was far more deliberate, a conversation conducted through sketches and calculations, through the language of steel thickness and ballast tank geometry, through the slow accumulation of small improvements that, when woven together, would create something measurably better than what had come before. The engineers and designers who gathered in these spaces understood something that only experience teaches. The Gato-class submarines had proven themselves, certainly. They were swift, reliable, and they had drawn blood across the Pacific. But they had also revealed their limitations, not through catastrophic failure, but through the quiet frustrations of commanding officers who wanted just a little bit more depth to hide at, more range to reach distant hunting grounds, more speed to evade the increasingly sophisticated escort vessels that now hunted submarines with grim determination. The Balao class had addressed some of these hungers, but there remained a hunger still, a sense among the submarine command that the next iteration could push further into territory both literal and figurative. What these designers began to sketch, therefore, was not a revolutionary departure, but something more refined, what might be called a systematic perfection of what had already been learned. They studied the stress patterns recorded in the hulls of boats that had already made their deep dives, reading the feedback written in the metal itself. They examined reports from submariners who had survived depth charge attacks, noting which compartments had held and which had flexed beyond their comfort. They considered the logistics of longer patrols, calculating how fuel consumption and crew endurance might be stretched further, without abandoning the core principles that had already proven sound. The thicker steel came first in the thinking, a deceptively simple improvement that required extraordinary precision in execution. The designers at both yards understood that you could not simply make the hull walls heavier everywhere. That would add weight without proportional gain in strength, and it would consume valuable tonnage that might be better spent on other systems. Instead, they began to imagine a hull of variable thickness, regions strengthened where stress accumulated most intensely, areas left slightly thinner where the submarine's geometry allowed it. This was not merely thicker steel in the abstract. It was thicker steel placed with the kind of mathematical care that came from reading the language that previous submarines had written in their deformations and their survivals. The calculations proceeded slowly, almost meditative in their pace. A pencil mark here on a blueprint, erased, redrawn. A slide rule, manipulated, checked, manipulated again. Conversations between men who understood that a difference of 1/8 of an inch in a pressure hull might mean the difference between a boat that could dive to 800 feet and one that could reach 850, and that additional 50 feet, in combat, in darkness, with depth charges thrumming overhead, might be the difference that mattered most of all. Alongside this work came a reimagining of where the submarine's weight and volume were apportioned. The fuel ballast tanks were being reconsidered, their arrangement thought through again with fresh eyes. Where should they be positioned to allow the deepest dive? How should they be distributed to maintain trim across the vessel's length as fuel was consumed during long patrols? The designers began to sketch configurations that allowed for longer legs, that submarine engineering phrase meaning greater range, extended operational endurance. A boat built for longer legs was a boat that could linger farther from port, that could reach into waters where enemy shipping might not expect predators to arrive. One might ask, lying there in the darkness, what drove men to such meticulous incremental work? There was no sudden inspiration, no eureka moment likely to be dramatized in a documentary or celebrated in a naval history. Instead, what moved these engineers was something quieter and more persistent, a knowledge that their work would eventually be entrusted to men who would take submarines into depths and dangers that the designers themselves would never witness. That responsibility, that weight of accountability, showed itself in the careful deliberation, in the way calculations were checked and rechecked, in the gathering of feedback from those who had already been to sea. The drawings accumulated, large, precise, detailed with the vocabulary of naval architecture, cross-sections showing frame spacing, longitudinal strength members, the distribution of weight and buoyancy. These were not mere technical documents, but rather the blueprints of ambition, the physical manifestation of a desire to build submarines that would be, in measurable ways, superior to what had preceded them. Slightly deeper crush depths, the maximum pressures at which the hull would remain intact, marginally longer endurance, additional fuel capacity, or more efficient systems that consumed less, perhaps a knot or two of additional speed, though this was balanced against other priorities. It is worth sitting with the reality that this work was not rushed. The war was urgent, yes. Enemy submarines were still sinking American merchant vessels and occasional warships. Japanese submarines hunted American surface fleets across the Pacific. But the submarine force leadership had learned that haste in design often became haste in failure, and failure in a submarine typically meant the loss not just of a valuable piece of military equipment, but of the 90 or so men whose lives depended upon that equipment functioning precisely as designed. So the designers at Portsmouth and Electric Boat took the time they required. They consulted with each other across the distance between Connecticut and New Hampshire, sharing sketches and ideas through official channels and through the informal networks of engineers who had trained together, worked together, understood together, the unforgiving mathematics of submarines. They studied the technical intelligence that was beginning to arrive about new German U-boat designs, some of which represented genuine advances in submarine technology. They wondered, as designers always do, whether they were imagining far enough into the future, whether their incremental improvements would be sufficient for the war that was still being fought and the wars that might follow. The world around these drafting tables was one of measured intensity, wartime but not frantic, strategic but unhurried. These men understood that their work was part of a larger tapestry of effort, and that their contribution would only be understood years hence, when submarines built according to their specifications either proved themselves in combat or proved insufficient. For now, they sketched, they calculated, they consulted with colleagues, they imagined the stresses that these hulls would endure, and tried, through the precision of mathematics and the care of engineering practice, to ensure that when those stresses arrived, the steel beneath the submarine would hold. And somewhere in that patient work of refinement and improvement, the outline of the Tench-Class submarine was beginning to emerge, not as a revolutionary breakthrough, but as a thoughtful, deliberate improvement on what had come before. A boat designed for depths slightly greater, ranges slightly longer, with systems slightly more refined. The designers could not have known, as they worked through 1943 and into 1944, that they were designing a class that would be born into a war that was already moving toward its conclusion. They knew only that they had a responsibility to make each new submarine better than the last, and that responsibility guided every pencil stroke, every calculation, every careful decision about where to place metal and where to permit openness, where to add strength and where to allow efficiency. The Tench-Class submarine represented, in its essence, a refinement born from hard mathematics rather than revolutionary vision. The engineers who sketched these hulls knew precisely what the Gato and Balao classes had taught them, and they built upon that accumulated knowledge with the patience of craftsmen who understood that small improvements, when compounded across a vessel's entire structure, could mean the difference between reaching a target and falling short, between surviving a depth charge attack and not. The welding of the hull itself marked perhaps the most visible departure from what had come before. Earlier submarines, particularly those of the Gato design that had carried the submarine war through its most critical phases, had been riveted. This was not a flaw exactly. Riveting was proven, reliable, understood by every shipyard worker who had driven a rivet home into steel plate. But riveting created what naval architects called stress risers, tiny interruptions in the structural continuity where each rivet hole sat like a small weakness waiting to be tested. A submarine hull at depth experiences forces that most surface vessels never encounter. The water pressure increases with relentless inevitability, squeezing from all directions, testing every join, every seam. The Tench-Class designers decided that welded seams would be superior. A properly executed weld, rather than creating a point of stress concentration, would blend the steel together into something closer to a single unified membrane. Did this make the hull dramatically stronger in absolute terms? The answer is more subtle than yes or no. What it did was distribute stress more evenly, reduce the likelihood of fatigue failure, and allow the engineers to operate their boats at depths where the Gato-class hulls would begin to show structural strain. This deeper diving capability, moving from operational depths of around 300 feet to something approaching 400 feet, though this figure must be understood as approximate rather than precisely documented, required more than simply thickening the hull or changing the welding method. The pressure hull itself, the inner steel cylinder that protected the crew from the crushing ocean around them, had to be reimagined in subtle ways. The Tench-class incorporated a hull form that was very slightly modified in cross-section, a refinement so small that it would be nearly invisible to the human eye. yet it changed the way water pressure distributed itself across the entire structure. The frames that reinforced the pressure hull were spaced with slightly different intervals in certain sections. These were the kinds of decisions that emerged from month after month of stress calculations performed by hand, by engineers working with slide rules and differential equations, knowing that every submarine they sent to sea would experience forces they could not fully predict. But the most practically significant change, the one that would be immediately apparent to any sailor who served aboard a Tench-Class submarine, involved the fuel and ballast tank arrangement. This was where the engineers made their boldest rearrangement of the internal landscape. Earlier submarine classes carried their fuel oil in tanks distributed throughout the boat, some outside the pressure hull in the double bottom, others wedged into spaces around and beneath the main compartments. This arrangement had worked adequately, but it created operational constraints. As fuel was consumed during a long patrol, the submarine's weight distribution would shift. The boat would need to shuffle water ballast between compartments to maintain trim, to stay level and stable in the water. It was rather like continuously adjusting your weight as you sat in a canoe, moving forward and backward to keep the hull riding at the proper angle. The Tench-class design moved away from this patchwork distribution. The fuel tanks were consolidated and repositioned to cluster more symmetrically around the boat's centerline. This seemingly modest change meant that as a submarine burned fuel over the course of a long patrol, and a Tench-class boat was built to patrol for weeks at a time, the weight loss would be distributed in a way that required less constant ballast adjustment. The submarine would maintain its trim more naturally, almost passively, without the crew having to wrestle the boat back into equilibrium every few hours. For the men who sailed these boats, this translated into something harder to quantify but deeply felt. The boat felt more stable, more docile, less fidgety in the submarine's peculiar dance with buoyancy. The machinery spaces themselves underwent quieter, but possibly even more consequential changes. Sound is the enemy of any submarine, the acoustic signature that can betray a boat's position to a listening enemy. By 1943 and 1944, this had become not merely an academic concern, but a survival imperative. Japanese forces had developed and deployed underwater listening devices with increasing sophistication. The Tench-class engineers knew this. They redesigned the ways in which the diesel engines mounted within the pressure hull were isolated from the hull plating itself. Vibration dampers, essentially rubber and steel sandwich structures, were improved in design and material composition. The exhaust piping was rerouted and supported in ways that reduced the transmission of machinery noise through the hull and into the water around the submarine. The electric motors that propelled the boat while submerged, running on battery power, also benefited from these refinements. The bearing supports that held the motor shafts in alignment were redesigned to minimize vibration. It is worth pausing here to consider what this meant in practical terms. A Tench-class submarine, operating under battery power at slow speed, moving almost silently through enemy waters, would produce less mechanical noise, less acoustic clutter, and therefore less warning to any listening device on the ocean floor or aboard an enemy vessel. In the context of submarine warfare, where detection often meant destruction, this was not a luxury feature. It was, in many respects, a life-saving modification. The designers also made adjustments to the ventilation systems that drew air from the surface when the submarine was operating in snorkel mode, submerged, but with a tube extended above the water to feed the diesel engines. The snorkel itself, that vulnerable periscope-like device, was refined in the Tench-class design to be somewhat more efficient, to require less exposure above the surface, to reduce the time during which a submarine might be spotted by an alert lookout aboard an enemy ship. These were incremental changes, yes, but in the calculus of submarine warfare, incremental changes accumulated into measurable advantages. What emerges from understanding these technical distinctions is a portrait of engineers who understood their craft with almost surgical precision. They were not building submarines that were fundamentally different in concept from the Gato or Balao classes. The overall layout, the arrangement of bow tubes and stern tubes, the general organization of the compartments remained recognizably the same. What they were doing was optimizing. They were taking everything that experience had taught them and translating those lessons into steel, into weld seams, into the precise positioning of ballast tanks and the careful isolation of vibrating machinery. Each modification served a purpose grounded in the knowledge that submarines built during 1944 and 1945 would need to operate against an enemy that was growing more desperate, more resourceful, and possibly more dangerous as Japan's situation deteriorated. What did the shipyards actually sound like when a Tench-Class submarine began to take shape in steel? The question sits quietly in the historical record, because most who wrote about submarines wrote about their patrols, their kills, their crew's terror at crush depth. But the true birth of these boats happened in places like Portsmouth Naval Shipyard in Maine, at Mare Island in California, and in the sprawling workshops of Electric Boat in Connecticut. Here the work moved with a different kind of urgency. Not the urgency of war itself, but the urgent, methodical pressure of building machines faster than they had ever been built before. In the autumn of 1943, when the first Tench-class hulls began their construction, the shipyards themselves had become something like cities within cities. Portsmouth Naval Shipyard, on the Piscataqua River, employed upwards of 15,000 workers by this point in the war. The sound of it was almost overwhelming. Riveters working in gangs would create a percussion so dense and layered that it formed something like a continuous roar, punctuated by the higher whine of pneumatic tools and the deep, grinding sound of massive machinery cutting and bending steel plates. A riveter himself would have heard little else during his 8 or 10-hour shift. The sound was in his body, felt through his feet on the metal deck plating, transmitted through his hands gripping the bucking bar that held the rivet in place, while another worker hammered it home from the opposite side. The welding was quieter in some ways, but possessed its own peculiar character. The electric arc welding that was increasingly used by 1943, replacing the older acetylene torchwork that had dominated shipbuilding for decades, produced a distinctive hiss and crackle, a bright blue-white light that could be seen from across the yard, even in daylight. A welder working on the pressure hull of a submarine, creating the seams that would have to hold against the immense forces of deep ocean, would have been bent into impossible angles inside the narrow hull section, wearing thick leather to protect against the intense radiant heat, working in the kind of intimate, echoing darkness that submarine hulls naturally contained. The joint he was laying down had to be nearly perfect. There was no room for weakness. Unlike a surface ship, where some imperfections might be tolerated, a flaw in a submarine's welded hull could mean the difference between a boat that returned to port and one that did not return at all. The day shift at Mare Island would have begun in the pre-dawn darkness, workers arriving by streetcar and personal automobile, flowing through the gates in a steady stream. By 7 in the morning, the yard was fully alive. The smell would have been distinctive, salt air from the bay mixing with burning metal, with welding flux, with the industrial smell of machine oil and hydraulic fluid. The steel itself, especially when it was first delivered to the yard, had a particular odor, that metallic iron smell that comes with fresh-cut plate and freshly delivered stock. As the Tench-class sections took shape, the yard would grow louder day by day. More riveters arrived. More welders. Sheet metal workers trimmed and fitted pieces that would eventually form the outer hull, the superstructure, the fair water that would house the conning tower. Electric Boat's facility at Groton, Connecticut, operated under slightly different conditions. The company was a private contractor, not a naval shipyard, and there was a different kind of atmosphere there, more competitive perhaps, and more attuned to industrial efficiency. Electric Boat had been building submarines since before the First World War, and their workers possessed an institutional knowledge that was valuable beyond measure. Older craftsmen, men who had built boats in the peacetime navy of the 1930s, worked alongside younger workers who had arrived during the war years, fresh from farms and small towns, learning the trade under conditions of wartime acceleration. The pace was relentless. A submarine hull was a complex assembly of thousands of individual parts, each of which had to fit perfectly with all the others. There was no margin for error, and yet the pressure to produce was constant. The smaller, more intricate work happened in the machine shops. The main engines, massive diesel engines that would power the submarine at surface, had to be fitted with extraordinary precision. The reduction gear, which would transfer the engine's power to the single propeller, had to be aligned to tolerances measured in fractions of an inch. The torpedo tube mechanisms, the ballast tank fittings, the intricate piping that would carry air, water, oil and refrigerant throughout the boat, all of this was fabricated in the machine shops, often using specialized equipment that had been custom-built for submarine construction. A machine shop supervisor, moving between lathes and milling machines, would have been attending to an orchestra of sound, the screech of high-speed cutting, the deeper grinding of heavy equipment removing stock, the clang of finished pieces being removed and stacked. The welders who worked on the internal structures had a different experience than those working on the pressure hull itself. Inside the submarine, on the non-critical structures, speed sometimes took precedence over absolute perfection, and yet there was still an awareness that these connections would be depended upon by living men and women once the boat was at sea. The sound inside a submarine under construction, moving through the narrow confines of the boat's interior, would have been almost claustrophobic in its intensity. The echo of tool strikes, the hum of power tools, the voices of workers calling to one another across and through the twisted passages, all of it contained and amplified by the steel walls that would soon form the boat's insides. There would have been moments of relative quiet, too, when a major section of the hull was being fitted into place, when a massive piece of equipment was being installed. The work would pause. Supervisors would check alignments. Measurements would be taken and retaken. The entire yard might hold its breath for a few minutes, waiting for the word that the fit was correct, the placement secure. These moments created a strange kind of suspense in the daily rhythm of shipyard work, long periods of intense, deafening activity interspersed with these careful, deliberate pauses where precision took precedence over speed. The night shift existed too, though it was smaller and quieter than the day shift. Under electric lights that turned the yards into something like artificial day, work continued. The continuous operation of the yards meant that a submarine hull never truly stopped being built. It was advanced toward completion in an endless cycle of human effort, and this meant that somewhere, all the time, someone was working on a Tench-Class submarine. The individual workers rarely thought in terms of the whole boat. They thought about their particular task, their section of the hull, their set of rivet lines, their seams to be welded. And yet, slowly, the submarine came together, piece by piece, from a collection of rolled steel plates and manufactured components, into something that would float, that would submerge, that would be crewed, that would go to war. The pace of construction accelerated through 1943 and into 1944. The Navy wanted submarines, wanted them desperately, and the shipyards responded with increasing efficiency. Production techniques were refined. Work crews became expert at their specific tasks. A team of riveters could complete a section of hull in less time as they became more practiced. The welders improved their speed without sacrificing quality, or at least the acceptable standard of quality was understood and practiced consistently. The larger the order became, and the Navy's order for Tench-Class submarines eventually numbered more than 100 boats, the more streamlined the process became. What had taken weeks in 1943 might take days by 1944, and all the while, in the machine shops, in the electrical workshops, in the pipe-fitting sections, the detailed work continued, turning the raw hulls into functional submarines, with all their systems integrated and tested. The lead boat arrived at the christening on a grey New England morning in October of 1944, her hull still bearing the scent of fresh paint and machine oil, her decks bare of the equipment that would soon crowd her interior spaces with the weight of war. The naming of a naval vessel carries a gravity that shipyard workers felt in their shoulders as they gathered along the rails and walkways, watching the ceremonial preparations unfold with the kind of patience that comes from knowing you have witnessed something you might never see again. USS Tench, named for a freshwater fish native to European and Asian waters. A quiet choice, perhaps, for a machine built to hunt the largest predators beneath any sea. The christening sponsor, as was custom, was a woman of prominence, and she stood waiting on the platform with the ceremonial bottle of champagne cradled in her hands, a gesture so ancient in maritime tradition that it seemed to carry within it all the launches that had come before. There exists a particular kind of nervousness among those tasked with breaking the bottle on the hull of a new submarine, for it was considered ill luck if the champagne failed to shatter on the first attempt. A submarine that proved stubborn to the christening blow might, some sailors believed, carry that stubbornness into whatever dangers awaited her at sea. The sponsor raised the bottle, drew it back with a steady arm, and brought it forward against the welded steel of the Tench's bow. The glass gave way in an instant, and champagne ran down the hull in streams that caught the pale October light. And somewhere in the gathered crowd, someone began to clap, and the applause spread like ripples outward. What does it mean to name a machine? To give it identity? To speak it into being as something more than mere assembled components of steel and copper and electrical wire? The Tench, like her sister ships, would now carry a name that would outlast her usefulness, would persist in memory and record long after her hull had been cut into scrap or rested on the ocean floor. The sailors who would serve aboard her would speak of her as the boat, but also as the Tench, as though she possessed something of the character of a living creature, something that responded to how she was treated, something that could save your life or fail you in the deepest moment of crisis. Whether this attribution of personality was merely comforting folklore or something more real, a subtle way in which the confidence and care of her crew became woven into her performance, remains a question that no amount of engineering analysis can quite resolve. The preparations for the launch itself followed a rhythm that had been established in American shipyards for generations, though the scale of submarine production during the war had compressed and refined these ceremonies into something efficient without losing its solemnity. The blocking and bracing were verified, the wooden shores and props that held the Tench in her building berth, preventing her from moving prematurely when the moment of release arrived. The launchways, those long sloping timber structures greased with a mixture of soap and tallow, were checked and rechecked to ensure they would allow the submarine to slide smoothly into the water without catching or binding. Every detail that might seem trivial to an observer carried enormous weight in the minds of the launch crew, for a submarine could be damaged during launch as easily as during months of combat, and a damaged boat might be lost before she had a chance to prove her worth. The water itself waited with a kind of neutral indifference, the harbour or river into which the Tench would slide neither welcoming nor hostile, simply present and ready to receive whatever came to it. One wonders, in those final hours before launch, What thoughts occupied the minds of the men who had built the boat, the welders who had sewn her hull together, the machinists who had fitted every valve and fitting into place, the electricians who had strung thousands of meters of cable through her compartments? Did they feel a sense of completion, a sense of letting go, some mixture of pride and uncertainty about what they had released into the world? The Tench was no longer theirs once she was launched. She belonged now to the Navy, to her commanding officer, to the men who would crew her, and finally, to whatever fates awaited her in the months and years to come. The final countdown in a submarine launch unfolded with a rhythm more akin to prayer than to machinery. The officials conducting the ceremony stood in their assigned positions. The launch director, having received confirmation from his team that all was ready, would give the signal. A man would approach the hydraulic or mechanical trigger that held the Tench in place, that single point of control that separated the boat from her immediate dive into the water. The moment stretched, they almost always did, those moments before release, and then, with a motion that seemed almost casual in comparison to its weight, the trigger was pulled. What happened next unfolded with a gentleness that surprised many observers, given the immense mass and force involved. The Tench, suddenly released from her shores and blocks, began to move. At first imperceptibly, almost undetectably, then with gradually gathering momentum. Gravity and the slope of the launching ways did their work, and the submarine that had rested in the berth since her keel was laid began her journey toward the water. The bands of the shipyard, if one was present, would strike up a march. The champagne still dripping from her bow caught the light again as she moved. Thousands of people watched in silence, the kind of silence that precedes an irreversible change, the kind of quiet that settles over a moment when everyone present understands they are witnessing something that will happen only once. The bow of the Tench met the water first, cutting through the surface with a sound that combined the splash of displacement with the deeper groaning of a hull finding its medium for the first time. Within seconds, more of her steel was in the water, and then it was happening at speed, the boat accelerating down the ways, the sound of her passage against the greased timber almost musical in its sustained note. Spray rose up around her as her full weight began to convert from the friction of the launching ways into buoyancy, the water transforming her from a static object into something that was beginning to move under its own emerging laws. It took only minutes, perhaps 5 or 6, for the USS Tench to be wholly in the water. The men who had guided her descent stood watching from the ways as she settled into her element, floating high and unballasted, riding the water like an object that had not yet decided whether it belonged there, but of course it did, and everyone knew it. The submarine's hull was designed by engineers who had spent their careers understanding water and steel and the complex interactions between them. Every angle, every thickness, every compartment and system had been conceived in anticipation of this moment and all the moments that would follow. The tugs came next, small and powerful vessels that moved alongside the floating Tench and took hold of her with their lines, ready to tow her into position, away from the launching ways and into the calmer waters where the real fitting out would begin. The work of building a submarine, in truth, was not finished at launch. It was merely entering a new phase. The equipment that had been held off, the torpedoes, the weapon systems, the sophisticated electronics, the supplies that would sustain a crew, all of this would come aboard in the weeks and months following the launch, transforming the empty shell into a functional weapon of war. But for this one moment, the Tench was something else. She was a vessel made manifest, a design made real, a hope and a fear, and an enormous expenditure of resources and skill given physical form and set loose into the world. The water held her gently. The light was beginning to fade from the New England sky as evening approached, and the shipyard was already shifting its attention to the next boat, the next launch, the endless cycle of production that characterized American submarine construction during the war years. The Tench floated, waiting, connected to the dock by her lines, but no longer connected to the land that had made her. She belonged now to the sea, and to the future, and to whatever trials and triumphs awaited her in the deep. The Tench-class was not imagined as a submarine for the war that was already being fought. It was imagined for the war that was coming. By 1943, when the design work had truly begun in earnest, American naval planners could see further ahead than the daily victories in the Solomon Islands or the atoll-by-atoll advance across the Pacific. They were thinking about what would happen when those island-hopping campaigns finally reached the doorstep of Japan itself. And that vision, that singular, enormous vision, shaped every choice the engineers made when they sat down with their slide rules and blueprints at Portsmouth Naval Shipyard and Electric Boat's Connecticut facilities. The war had already taught the submarine force harsh lessons about what endurance meant. A Gato-class boat could remain on patrol for perhaps 50 to 60 days, but that assumed careful consumption of fuel, measured use of battery power, and the discipline of a crew who understood they were always, in some sense, running on borrowed time. The Tench-class designers asked a different question. What if a submarine could stay away longer? What if it could push further into enemy waters, remain on station deeper in Japanese territory, and still return safely to port with fuel reserves intact? That hunger for endurance became the spine of the design. They began with the hull itself, understanding that a stronger, more efficiently welded pressure hull could not only withstand greater depths, a crush depth now designed to exceed 1,000 feet, deeper than any submarine had been forced to go in combat conditions yet, but that this same strength could be achieved with less weight, which meant less drag, which meant better fuel efficiency, which meant longer legs. The mathematics of submarine design spiral in on themselves this way, each improvement feeding into another. Thicker steel, fewer rivets, smoother welds, a frame that held together like a single continuous thought, rather than like a collection of riveted plates that could never quite be entirely watertight. The engineers at Electric Boat had been quietly studying what the British were learning from their own submarine developments, and what the Germans had proven through trial and terrible error beneath the Atlantic. Welding was the future, they understood. Fewer seams meant fewer places for pressure to exploit, fewer places for failure. But the endurance they were chasing went beyond hull strength. It went into the very tanks that held the submarine's lifeblood. The Tench-class design rearranged the fuel ballast tanks, spreading them more intelligently throughout the boat's length and cross-section. A submarine carries fuel in some spaces, seawater ballast in others, and the relationship between them is never simple. Too much weight in one place, and the boat becomes sluggish, or worse, becomes difficult to trim and control. But the designers understood something else. If you could distribute the fuel load more evenly, if you could pack more fuel into the same external dimensions, if you could optimize the balance between heavy fuel storage and the displacement of the boat itself, you could extend range without necessarily making the submarine longer or wider or more visible to enemy sonar. The invisible answer to endurance, in other words, was better engineering in the spaces below the deck plates, where no one who wasn't part of the crew would ever see it. The machinery spaces themselves underwent a quieter revolution. Diesel engines in a submarine are not quiet things. The Gato and Balao classes had already pushed diesel efficiency further than anyone thought possible, but they still carried with them the fundamental rattle and throb of older naval engineering. The Tench-class introduced newer, more tightly fitted engines, vibration dampers that were refined in their isolation, exhaust systems that were re-engineered to reduce radiance into the surrounding water. A quieter submarine was not necessarily faster, but it was something equally valuable to the men who crewed it and the officers who commanded it in enemy waters. It was more survivable. Quietness meant the enemy's listening devices, and by 1944, the Japanese were developing better hydrophones, better listening arrays, had a harder time detecting you. Quietness meant you could run your engines longer, push harder, remain unheard. For a boat designed to penetrate deeper into enemy territory than any submarine had been expected to do, quietness was another form of armor. The fuel bunkers of the Tench-class could hold something in the neighborhood of 100 tons more than their predecessors, and this was accomplished not through bulk, not through making the boat larger in any visible way, but through subtle shifts in tank geometry, through the replacement of riveted tanks with welded ones, through the meticulous recalculation of how much volume could be squeezed from every cubic foot of the submarine's internal space. Picture the design team, bent over their blueprints in the lamplit offices as 1943 turned toward 1944, using logarithmic tables and steel rules to locate fractions of gallons where earlier designers had seen only closed possibilities. They were designing a boat that could stay submerged longer, that could operate farther from its supply lines, that could loiter in dangerous waters and still make the return journey home. And beneath all these technical decisions lay a question that was never explicitly stated in official documents, but which everyone understood. What was this submarine actually for? The answer, when you listened to the war planners, was the same answer that had animated every major shipbuilding decision since 1942. The submarine force was preparing for Operation Downfall. That was the code name for the planned invasion of the Japanese home islands, an operation that strategic planners believed would be necessary, inevitable, and possibly the costliest military operation in American history. In that invasion, submarines would have a role that was at once different from and more demanding than anything they had been asked to do so far. They would operate off the coasts of Japan, not in twos or threes, but in coordinated groups. They would need to remain on station for extended periods, providing reconnaissance, interdicting supplies flowing to shore, disrupting the enemy's defensive preparations, and standing ready to report any movement of Japanese capital ships that might threaten the invasion fleet itself. For that mission, endurance was not a luxury. It was a requirement that shaped the boat from its deepest ribs to its superstructure. The Tench-class was engineered around the assumption that the war would last long enough, would push far enough toward Japanese soil, that these boats would need to be capable of sustained operations in waters where friendly surface support was minimal, where resupply was not easy, where a damaged submarine might need to limp hundreds of miles back toward safety. The designers were building a submarine that could be injured in combat and still bring itself home. They were building a submarine that could stay away from port longer than any boat before it. They were building, in essence, for an endurance that matched the time horizon of the entire Pacific War, as it was understood to extend forward from 1944. And yet, in the way of history, these boats were being completed just as the calculus was changing. The war would not last as long as anyone imagined. The Japanese home islands would not be invaded by seaborne assault, for reasons that would become clear only after uranium and enriched plutonium had already rewritten the future of warfare itself. But the submarines did not know this. They were built for an invasion that never came, and they carried within their welded hulls the intention of their designers to enable that operation, to make that operation possible, to give the crews who would man them the best chance of survival and success in what would have been the bloodiest chapter of the Pacific War. The Tench-class, then, was a submarine built for tomorrow, while today's war was still being fought around them. Every improvement in depth, every extension of range, every refinement in quietness pointed toward a future that would never arrive in quite the form the planners had imagined. But the engineering was real, the capability was real, and when these boats finally began to slip down the ways and into the water, one after another, from 1944 onward, they carried with them the hopes and assumptions of men who believed the war would endure for years longer than it actually would. The submarine that left port was, in one sense, a machine, a precise arrangement of steel and machinery and systems designed to move silently beneath the surface. But once the hatches dogged shut and the boat slipped away from the dock, it became something else entirely, a floating world, sealed and self-contained, where perhaps 100 men would live out weeks or months in spaces so confined that privacy was not merely scarce, but essentially impossible. To understand what it meant to serve aboard a Tench-class boat was to understand something about the rhythm of existence at sea, about the way human bodies and minds adapted to circumstances that were, by any ordinary measure, utterly alien. The crew divided themselves not by rank alone but by function, and those functions determined everything: when they slept, what they ate, what sounds they heard during the long hours of darkness. The submarine ran on a schedule of watches, rotating periods of duty that kept the boat under constant attention. 4 hours on watch, 8 hours off, or sometimes 6 and 12, depending on the captain's preference and the demands of the moment. That rhythm became the skeleton around which all other activity hung, the grinding sameness of days where light never changed, where the clock was the only marker of time's passage. Some men preferred the daylight watches, the hours spent in the conning tower or at the periscope, where at least the illusion of connection to the world above remained. Others found the night watches easier, though of course there was no true night in a submarine, no stars visible through the hull, nothing but the steady hum of the diesel engines when they ran on the surface, or the deeper, stranger silence when submerged and running on batteries alone. The men ate well, if you measured well by calories and weight. The submarine service understood that feeding the crew adequately was essential, not for morale alone, though that mattered, but for the sheer physics of men performing precise tasks in a confined space while absorbing a degree of psychological strain that was almost impossible to describe to someone who had not experienced it. The cooks worked in galleys that were themselves constricted compartments, yet they managed to produce meals that were almost certainly better than what men were eating in the trenches or in the gun batteries ashore. Fresh meat in the early weeks of a patrol, vegetables and bread baked from scratch, coffee that was kept hot and strong. The meals became a sort of punctuation mark in the day, something to look forward to, something to gather around, even if gathering meant standing in a narrow passage eating from a tin plate. One imagines the smell of food carrying through the boat, the way the galley became a kind of social center, a place where men could, for a few moments, step slightly outside the weight of the boat's mission. But the rhythm of sleep aboard a submarine was something altogether different from sleep ashore. Men learned to sleep in bunks that were stacked 3 or 4 high in some compartments, bunks so narrow and short that even a man of average height had to bend his legs or fold his frame in ways that seemed to defy geometry. Worse, because of the rotation of watches, the bunk you slept in might not be your own at all. You might sleep in a bunk that another sailor had just vacated, his warmth still embedded in the mattress, his presence still somehow lingering in the fabric. This was called hot bunking, and it was not a convenience, but a necessity, born of the simple fact that there were more men than there were places to sleep. You learned to fall asleep quickly because your time in the bunk was limited. You learned to sleep through sounds that would have kept an ordinary person awake: the distant grinding of the electric motors, the hiss of compressed air being used to operate valves, the footsteps of men moving through the boat at all hours. You learned to wake instantly when your watch came due, pulling yourself from sleep the way one might pull oneself from water, gasping, already moving. The meals and watches and sleep were the structure, but underneath them flowed something more subtle and harder to articulate, an awareness of depth. Men lived with a constant, barely conscious knowledge that the only thing between them and the crushing weight of the ocean was the steel around them, and that steel had a limit. The submarines were built to dive deeper than their predecessors, to withstand greater pressure, but every man aboard knew the numbers. The test depth was one thing, the depth to which the boat could go and still operate normally. But there was also the crush depth, the theoretical point at which the pressure would simply collapse the hull, and beyond that lay only darkness and weight and the end of everything. This knowledge was not usually discussed. It was simply there, a fact as unremarkable and as ever-present as the sound of the engines. You did not think about it the way you thought about ordinary fears. It was too absolute for that, too much a simple statement of natural law. When a submarine was running silent, when the boat had detected enemy vessels, and the captain had ordered all unnecessary machinery shut down and all men to remain as quiet as possible, something else happened entirely. The silence itself became almost tangible, a presence in the boat. Men stopped walking in the normal way and instead moved in a kind of gliding shuffle, placing their feet with care so as to avoid the slightest noise. Conversations ceased. The only sounds were those that could not possibly be stopped, the soft hiss of the air systems keeping the atmosphere breathable, the almost inaudible creak of the hull as it adjusted to pressure changes. In the engine room, men stood motionless for hours, monitoring gauges, ready to make adjustments but moving as little as possible. In the torpedo rooms, the crew waited with their weapons fully loaded, watching and listening. In the conning tower, the captain and his executive officer and the sonarmen remained at their stations, focused entirely on the sounds carried through the water from whatever enemy vessel had attracted their attention. What happened next, the thing that defined so much of what submarine service meant, was the depth charge attack. The enemy would have detected the boat somehow, or suspected its presence, and would begin to drop charges, trying to force it to the surface or damage it beyond repair. The charges were not subtle instruments. When they detonated, they sent shock waves through the water with enormous force, and those shock waves transmitted themselves directly into the hull of the submarine, shaking it violently, throwing men against bulkheads, loosening fixtures, testing the welds and rivets and steel plates that held the boat together. The experience was utterly unlike anything else, a sustained, overwhelming assault on the senses, made worse by the fact that the men inside could do almost nothing but wait and endure. The captain might attempt evasive maneuvers, changing depth or course, trying to confuse the enemy's sonar or throw off their calculations, but fundamentally, the boat was a target, and the men inside it were trapped. During these hours, and they could last for many hours, the crew existed in a state that was somewhere between absolute terror and a kind of dissociated calm. The body understood danger and wanted to react, but there was nowhere to go and nothing to do except continue breathing and watching the depth gauges and listening to the sounds of the engines working at their maximum effort to keep the boat moving. Men prayed or did not pray, according to their natures. Some spoke quietly to each other, others remained completely silent. The air grew thick and stale as the systems worked to keep it breathable. Sweat accumulated on the walls and on the men's skin. The boat itself, which had become by necessity a kind of friend to the crew, a mechanical companion whose sounds and movements they knew more intimately than any living thing, became a source of anxiety, every creak and groan suggesting possible damage, possible failure. The Tench-Class submarines were built knowing that their crews would experience this again and again, that the hulls would need to withstand not just normal operation, but the terrifying violence of being hunted. The thicker steel, the improved welds, the deeper crush depth, these were not merely technical specifications. They were responses to the knowledge of what these boats and these men would face. Every improvement in the design was made with this specific kind of endurance in mind, not the smooth running of the engines or the elegant lines of the hull, but the capacity to survive, moment by moment, while death literally fell from the sky. By 1944, the submarine war in the Pacific had begun to shift beneath the surface in ways that the desk charts at Navy headquarters could barely capture. Admiral Chester Nimitz, commanding the vast sprawl of the Pacific Fleet, found himself at a threshold. The submarines under his command were no longer simply raiding merchants and tankers along distant shipping lanes. They were becoming, increasingly, the long knife in an empire's side, and the Tench-class boats being christened and slipped into the water were designed with a different strategic hunger in mind. The earlier submarines, the Gatos, the Balaos, had been built with a singular purpose burned into their hulls: commerce raiding, sink the transport, starve the nation, watch its war machine grind towards stillness. And they had accomplished this with a kind of quiet ferocity, year after year. But by 1944, the picture had transformed. The Japanese home islands sat defended by a shrinking fleet, by aircraft growing fewer, by pilots whose training hours had compressed almost to nothing. The question that had begun to form in the minds of submarine commanders and fleet strategists was no longer how to weaken Japan economically, but how to prepare for an invasion that seemed, for the first time, genuinely possible. Operation Downfall, it would be called, the planned invasion of the Japanese home islands, an operation of such magnitude that even to speak its code name in whispers sent tremors through the planning rooms at Pearl Harbor. And submarines, those patient machines that could reach where surface fleets could not, would play a role unlike anything they had yet attempted. They would be sentries, they would be wolf packs, coordinated and predatory, tasked with strangling the final remnants of the Japanese Navy before American soldiers could possibly set foot on Japanese soil. The submarines would hunt not just merchant ships, but warships. They would interdict, they would deny, they would prepare the waters themselves for invasion. This reorientation of purpose had come gradually, then all at once. In the spring and early summer of 1944, as the debates continued in Washington and the Joint Chiefs of Staff weighed the costs of different invasion strategies, Nimitz and his submarine commanders, men like Vice Admiral Charles Lockwood, who ran the submarine force from Pearl Harbor, began to reshape how submarines would be deployed. No longer would they be scattered across the vast Pacific in loose formations, each captain hunting independently. Instead, wolf packs would form, 3 submarines, sometimes more, coordinated by radio, working in concert to trap and destroy larger targets, to deny the enemy the use of critical waters, to gather intelligence on enemy movements that could inform the larger invasion strategy. The technical demands of this shift were subtle but profound. A Tench-class submarine built for wolf-pack operations needed endurance, the ability to remain on station for long patrols, to circle and wait and strike when the moment came. It needed to be quiet, because coordination meant communication, and communication meant radio signals that the enemy might detect. The machinery spaces of the Tench-class, with their improved sound dampening and their rearranged ballast tanks, were engineering answers to this strategic demand. Deeper crush depths, which the thicker welded hulls provided, meant that a boat could dive below the acoustic layer, that threshold of water where sound behaves differently, and disappear from the destroyers hunting it. The longer fuel capacity meant extended patrols, weeks on station rather than days, waiting for the convoy that might come, or the warship whose location had been only roughly guessed at from intelligence reports. What was being constructed, in other words, in the shipyards and on the design tables, was not merely a better submarine. It was a machine designed around a very specific future, the future of Operation Downfall. The boats being launched in 1944 and 1945 carried within their steel bones the assumption that the war would continue, intensify, that American forces would need to ring the Japanese islands with submarines before the invasion could proceed. Every rivet, every weld, every foot of additional diving depth, and every extra ton of fuel oil was an investment in a conflict that everyone understood would grow bloodier before it ended. In the submarine command's war rooms, the maps on the walls showed something remarkable. By the middle of 1944, the Japanese merchant fleet had been reduced to a fraction of what it had been just 2 years prior. The transportation arteries that had once pumped resources from conquered territories back to the home islands were nearly severed. Yet still the submarines continued to be built. Still the Tench-class hulls were sliding down the ways at Portsmouth and Electric Boat and Mare Island. Why, one might wonder, build the most advanced submarines of the war, just as the enemy's ability to use the sea was almost gone? The answer lay in what was coming next. The answer was downfall. The answer was the knowledge, shared by only the highest circles of command, that the war would not simply end through attrition and blockade. It would end only when American forces stood on Japanese soil. And for that to happen, for that to be possible, without casualties so catastrophic that they might reshape the nation itself, the submarine force needed to be transformed. From hunters of merchant ships to sentries for invasion, from raiders to instruments of strategic denial, the Tench-class boats, with their increased capability and endurance, with their thicker hulls and deeper operating depths, were built in the image of this new role. They were, in a sense, the physical manifestation of a strategy that had not yet been fully tested, a fleet within a fleet, designed for a war that was shifting shape even as the boats' keels were being laid. By late 1944, as the first Tench-class submarines began to enter active service, the submarine force had grown into something vast and coordinated. Lockwood controlled dozens of boats. Intelligence networks stretched across the Pacific, reporting on enemy movements, weather, the location of convoys and task forces. The submarine command had evolved, in these 4 years of war, from a somewhat improvised and scattered force into something approaching a unified strategic instrument. And the Tench-class submarines, with all their technical refinements and increased capability, were the newest iteration of this instrument. Boats that would function as the eyes and teeth of the invasion force, whatever form that invasion might eventually take. The first Tench-class submarines to reach the Pacific carried with them the accumulated knowledge of 3 years of submarine warfare in the American Navy. They did not arrive as pristine, untested designs sent blindly into battle, but rather as refinements born from hard lessons, from boats that had come before them, from crews who had learned what worked and what cost them dearly in the depths. And so when the lead boat, USS Tench herself, slipped from her moorings at Pearl Harbor in the spring of 1944, she carried not just the hopes of her builders, but the weight of all those hard-won improvements that would be tested now against a real and resourceful enemy. The patrol reports that came back told of a different kind of submarine war than had been fought in the earlier years of the conflict. The waters around Japan and her outer islands were no longer teeming with the vulnerable merchant traffic that had made the first submarines' patrols so deadly profitable. The Japanese had learned. They had become more cautious, their merchant fleet smaller and more heavily guarded, their naval escort tactics sharper and more coordinated. Yet still the boats went out, and still they hunted, and the Tench-class submarines were particularly well suited to this harder, more patient kind of warfare. Consider USS Tench's first war patrol, stretching from April into June of 1944. The boat and her crew of 80 or so men operated in the waters near the Marianas, watching shipping lanes, reporting on Japanese naval movements, looking for the heavy units that might justify the risk of a full approach and attack. Sonar operators sat in their compartment in the darkness, ears attuned to the subtle vibrations that spoke of a distant propeller, a chance, a moment of opportunity. The improved, quieter machinery spaces of the Tench-class hull meant that the boat itself made less noise, a small but crucial advantage when the enemy had begun placing hydrophone networks and training their escort crews to listen as intently as the American submariners listened for them. What did those early patrols reveal about the boat's actual performance at sea? The thicker welded hull that engineers had labored over allowed deeper dives without fear, to depths where the sonar reflections became less clear and the acoustic environment more forgiving to a boat trying to slip away from pursuing destroyers. The improved ballast tank arrangement meant better stability in the deep, less violent flooding in the event of a near miss from a depth charge, a margin of safety that might mean the difference between a boat that limped back to port and one that never returned at all. USS Tench herself found targets during those early patrols: small ships, patrol vessels, the occasional larger prize, though nothing that would single out her name for special glory in the annals of submarine warfare. She and her crew performed their duty with steady competence, and that steadiness was itself a kind of triumph, a vindication of the design philosophy that had guided her construction. The Tench-class had been built to endure, to persist, to maintain their hunting presence in enemy waters for longer than previous boats could manage. Other boats of the class were joining her in the Pacific waters even as her first patrol unfolded. USS Threadfin made her first voyage under the command of William B. Peroni Jr., a captain who understood the new calculus of submarine warfare, the shift away from the early days of individual heroics toward coordinated efforts with other boats, toward supporting the larger strategic movements that Nimitz was orchestrating across the Pacific. The Threadfin operated in wolf packs sometimes, small coordinated groups of submarines that could overwhelm a convoy's defenses more completely than a single boat could manage alone. The Tench-class submarine, with her improved engineering and longer range, was well suited to this kind of coordinated hunting, able to maintain station with other boats for days on end without falling behind or straining her machinery. The patrols themselves followed a familiar, if exhausting, rhythm. Days of steaming submerged through daylight hours, listening, watching the periscope slice through calm or turbulent water, depending on the weather topside. The crew would rest in shifts, sleeping in the narrow bunks that were stacked 3 high in the torpedo room, the berthing compartments, anywhere space could be found. Food was prepared in a galley that was scarcely larger than a closet, yet the cooks managed to produce meals that sustained the men through weeks at sea, dishes rich enough to be remembered years later by sailors who had known no hardship but the grinding monotony and occasional terror of submarine operations. When enemy vessels appeared on the horizon or were detected at a distance by sonar, the atmosphere aboard would shift in ways subtle but unmistakable. The boat would go to general quarters, men moving to their combat stations with practiced efficiency. The sound-powered telephone circuits would come alive with quiet, professional voices calling out bearings and distances, torpedo room personnel preparing the forward tubes, the captain and his fire control officer plotting an intercept course, calculating the angles and speeds and the moment when it would be time to shoot. In those moments, the Tench-class submarine's quieter machinery became truly precious. The difference between being detected and remaining unseen, between launching a surprise attack and being discovered before the torpedoes could leave the tubes. Yet something was already beginning to shift in the nature of the war at sea. By the middle of 1944, when these first Tench-class patrols were underway, American submarine losses had become notably fewer than in earlier years. The Japanese anti-submarine capabilities had not improved markedly, but American tactics had become far more sophisticated, American boat commanders far more experienced and cautious. The new submarines carried better sonar, better fire control systems, better torpedoes, though the Mark 14 had only recently been fixed of its chronic running too deep problems that had plagued submarine operations for years. And the men who crewed them had learned, from predecessors' mistakes and sacrifices, how to fight a submarine war against an increasingly cornered and desperate opponent. USS Tench and her sister ships would continue their patrols, continue to hunt and to report, continue to slip through waters that had become, by the standards of 1944, considerably safer for American submarines than they had been in the early years of the war. They were building their record of patrols and kills, small additions to a larger tally that would never reach the numbers some had dreamed of, because the enemy merchant marine was simply running out of ships to sink. But they were doing their duty, testing the designs that had been committed to them, proving that the improvements made at the drawing board and in the shipyards did indeed translate to meaningful advantages when the boats were finally put to the test. The question that hung unspoken over all these patrols, all this steady, competent hunting in enemy waters, was how much longer there would be to hunt at all, how much longer the enemy could continue to resist. The engineers and designers who had created the Tench-class had imagined them serving for years, perhaps decades, in a long war against Japan. But time, that quiet conspirator in all human affairs, was weaving a different story than anyone yet imagined. The Mark 14 had been a ghost in the machine for years. In the early campaigns across the Pacific, submarine commanders returned from their patrols with stories of hits that hadn't detonated, of their torpedoes sliding beneath enemy hulls without firing, of mechanical failures that had cost them kills they should never have missed. The warhead would strike, and the contact exploders would fail. Sometimes the magnetic detonators misfired. Sometimes they fired too soon, sometimes too late, sometimes not at all. In the darkness below, crews had learned to live with a weapon that promised everything and delivered uncertainty. But by 1944 and into 1945, something had changed quietly in the ordnance shops and testing ranges. The Navy's Bureau of Ordnance had finally, after years of stubborn resistance and careful field analysis, begun to understand what the submariners already knew from bitter experience. The magnetic exploders worked inconsistently in the varying magnetic fields of different ocean regions. The contact exploders were too sensitive, detonating on approach rather than on impact. There had been pride involved in the resistance to change, the belief that the Mark 14 was a sound design, that the failures belonged to the men who fired them. But the men who fired them knew better. The solution, when it came, was almost mundane in its simplicity. Engineers developed a much improved contact explorator plate, a mechanism that required a harder, more certain strike before the firing pin could drive home. They refined the electrical circuits. They gave submariners the option of running their torpedoes with the magnetic feature switched entirely off, trusting instead in the pure mechanical shock of a direct hit. It sounds like a small thing, but in the submarine service, small things were the difference between returning home and not returning. For the crews of the Tench-class boats and other submarines that received these improved fish, something shifted in the long silence of patrol. They had confidence now, not certainty. The sea never offered that, but confidence. They could trust their weapons the way warriors had always needed to trust their weapons. The torpedo now became an extension of the crew's intention rather than a source of doubt. When a Tench-class boat lined up on a target, when the crew heard the order to fire and felt the gentle kick of compressed air expelling the weapon into the ocean, there was a new calm that settled into the compartments. The torpedo they had released would do what it was supposed to do. The Japanese themselves had been perfecting their own torpedoes throughout the war, and their Type 93, the famous Long Lance, was in many ways superior to American designs. But the Long Lance suffered from its own complexities, its own vulnerabilities, and by 1944 and 1945, there were fewer Japanese ships to sink them. The asymmetry had tilted. American submarines were now equipped not just with better boats, but with weapons that actually worked as intended. Consider what that meant in the tactical moment. A Tench-class captain, having maneuvered into position, could now calculate a firing solution with the expectation that his mathematics would be answered by a hit. The psychological weight of that cannot be understated. In earlier years, a captain might have fired a full spread of 6 or 8 torpedoes, hoping that at least one might detonate. By 1944, a more conservative and confident captain might fire fewer torpedoes with greater assurance of result. Fuel and ammunition mattered, endurance mattered, and a boat that could sink a target with 4 reliable weapons rather than 8 unreliable ones could patrol longer and range farther. The Tench-class boats, being among the newest designs in the submarine force, were the first to receive these improved torpedoes in consistent fashion. There was something like a partnership forming between hull and weapon, between the steel design of the boat itself and the ordnance it carried. The engineers who had spent hours at Portsmouth and Electric Boat refining the submarine's hull and machinery had finally met, in the ordnance shops, with weapons that matched their ambitions. Testing facilities across the United States, at Newport, Rhode Island, and other stations, had run thousands of trials in 1943 and 1944, exploring exactly what conditions caused the Mark 14 to fail and what configurations allowed it to succeed. This was meticulous, tedious, unglamorous work. No one wrote poetry about it. The testing was done mostly by quiet professionals, engineers, and ordnance men who understood that their work would either send crews home or not bring them home at all. The rumours and accounts from returning skippers had finally forced the issue. The submariners had kept records, in their own way. They noted their shots and their results. They had become, in effect, field researchers running experiments in a vast and terrible laboratory. And their data, accumulated over hundreds of patrols, had finally overwhelmed institutional reluctance to admit that the Mark 14, as originally conceived, was fundamentally flawed. By the time a Tench-class boat went to war, this matter was largely settled. The crew could trust their tubes. There was still uncertainty in combat. There always would be, but the mechanical uncertainty had been stripped away, or at least reduced to manageable levels. A torpedo fired from a Tench-class boat in 1945 would run true. It would track its course. If it met a target, it would detonate. This was not destiny, but it was something the crews could depend upon. And in the close, steel-walled world of a submarine, where men lived with danger as their constant companion, where every decision was made in darkness and at depth, the ability to trust one's tools was almost as important as the tools themselves. The Tench-class boats, then, carried into the final months of the Pacific War an advantage that earlier submarines had been denied. They carried reliable weapons. They carried the expectation that their sacrifice, if sacrifice came, would not be meaningless. The war, though neither the designers nor the crews could have known it with certainty, was entering its final chapter. The Tench-class boats were being completed at an accelerating pace. They were being armed with torpedoes that worked. They were being crewed with some of the most experienced submariners in the fleet. Everything was prepared for an invasion of the Japanese home islands that would require their services, their endurance, their courage. Everything was ready for a war that would end before they arrived. The men who designed the Tench-class understood, with a quiet certainty that lived in the back rooms of Portsmouth Naval Shipyard and Electric Boat's Thames River plant, that these submarines would not be instruments of quick victory. They were being built for endurance. They were being built for a war that had, by 1944, already stretched 3 years longer than anyone in 1941 had imagined it would, and they were being built with the understanding that it might stretch 3 years more. Because in the planning rooms of the Navy Department, and in the map-covered offices where Admiral Chester Nimitz's staff moved markers across the Pacific, there existed a plan that had a name. Operation Downfall. And Operation Downfall was not a contingency whispered in confidence. It was real. It was being resourced. It was, in the minds of those who studied submarine service records and attrition rates and fuel consumption and the vast geometry of the Pacific Ocean, the most likely shape of how this war would actually end. Downfall imagined an invasion of the Japanese home islands. Kyushu first, in the autumn of 1945, Honshu after that, in 1946. Millions of troops landing across black sand beaches under fire from an enemy that, unlike the Germans facing encirclement, would be defending their own soil. The planners knew what that meant. Casualties that would dwarf anything the Pacific theater had yet seen. Supply lines stretched across an ocean so wide that every ton of ammunition, every drop of fuel, every case of K-rations for soldiers would have to travel further than any supply line in the history of warfare. And standing between the American fleet and those supply lines would be Japanese submarines, Japanese mines, Japanese aircraft, flown by pilots with nothing to lose and everything to fight for. The Tench-Class, in this architecture, was part of the answer. Not just a hunter of merchant shipping, though that remained the work, but a carrier of supply, potentially, a provider of reconnaissance far forward, a boat that could stay on station for months if needed, that could operate at depths where even the newest Japanese depth charges might struggle to reach. The thicker hull, the better welding, the improved arrangement of fuel ballast tanks that gave the submarine crew extra days of range. All of this made quiet sense when you were building not for the war as it was, but for the war as it was expected to become. And so the boats were launched into a strange temporal space. They entered the water as instruments of a future conflict that was simultaneously growing more likely and more remote. The farther the war pushed into 1944 and into 1945, the more the Naval Command's eyes turned toward the long game. Japan was weakening, yes. Her merchant fleet was scattered across the bottom of the ocean. Her refinery capacity was in ruins, and yet she would not surrender. The island nation contracted around its center, digging in, fortifying, waiting. And every day that she did not surrender was one day closer to downfall. The crews who reported aboard these Tench-class boats in the final year of the war must have felt something of this tension. They trained on equipment that was still being refined. They drilled in darkness and in simulated depth charge attacks. They learned to move through narrow corridors with the kind of practiced silence that only comes from the understanding that your life depends on not being heard. And all of this training, all of this discipline, all of this long preparation happened under the shadow of an operation that had been planned for, funded for, designed around. An invasion that was coming, that had to be coming, because the alternative, a war with no end, was unthinkable. What might the men in the forward torpedo room have thought as they fitted the Mark 18 electric torpedoes into their tubes? These were new weapons, improved designs, far more reliable than the infamous Mark 14 that had plagued earlier boats. Here, at last, was a weapon worthy of the risks they took, and they were taking these risks because the command had told them, in so many words and in the silence between the words, that there was still so much more to come. The submarine service had already learned to live with contradiction. The boats conducted their war patrols into 1945, knowing that they might encounter the Japanese Navy in full retreat or in desperate last stands. Some patrols lasted 60 days, some lasted 90. The men's hair grew long. The air grew thick in the compartments. The smell of diesel fuel and sweat and canned food became so familiar that a man returning to land felt almost displaced by the memory of fresh air. And beneath all of this lay a curious form of temporal uncertainty. Were they conducting the final offensive of one war or the opening campaign of another? The officers in the wardroom, The commanding officers and the executive officers and the torpedo officers read their dispatches and their patrol orders with knowledge that was both clear and opaque. They were being sent to intercept Japanese shipping. They were being sent to gather intelligence on coastal defenses. But they were also, perhaps, being sent to learn the waters where an invasion fleet would have to move, to understand the currents and the reefs and the depth contours where transport ships would be most vulnerable, to place themselves where they would need to be when downfall became not a hypothesis but a date on a calendar. There is something almost unbearable, in retrospect, about this quality of preparation. The boats were being built better, crews were being trained harder, the doctrine was being refined. All of it was being done for an event that was approaching, that seemed inevitable, and that stood poised above the war, like a dark cloud formation that everyone could see, but no one could yet touch. Some of the Tench-class boats, not all, but some, would make it into the war before the end came. They would fire their torpedoes, and in some cases they would strike targets, and see, in the small way that submariners could see results in a black ocean, the consequences of their work. Other boats would complete their construction and their sea trials and their workups with the training commands only to find, in August of 1945, that the war had ended, that Operation Downfall would not happen, that the ships they had been built to support an invasion for would never sail, that they had been engineered for a future that had suddenly ceased to exist. The tension that lived in those boats, the tension between preparation and purpose, between the war that was being fought and the war that was being planned for, between the young men in the crew's quarters who understood they might die in an invasion, and the political decisions that would, before they could be made, be superseded by physics and fire and the sudden surrender of an exhausted nation. That tension is perhaps the most human thing about the Tench-class. They were born into the expectation of a larger war. They were built with the equipment and the hull design and the endurance to fight it. And then, in a moment, they were not needed for that war at all. What becomes of a warship when the war ends while it's still being built? The question carries a peculiar sadness, one that the Tench-class submarines embody in ways few other vessels quite do. By the summer of 1945, as the final preparations for Operation Downfall were being finalized, as invasion planners were drawing up beach codes and rehearsal schedules, the shipyards at Portsmouth Navy Yard and Electric Boat in Groton and Mare Island were still launching these vessels at a steady, purposeful pace. The kilns were still hot. The welders' torches still carved their bright lines through steel plate. The noise of construction had not yet quieted, yet already, in the highest councils of war, in the offices where admirals and men in suits studied maps and photographs, the underlying calculation was shifting. Japan was collapsing. Supplies were failing. The cities were hollow with hunger and ash, but the hulls kept coming down the ways. Consider the chronology of those final months with the gentleness that distance and time allow. In June of 1945, USS Trumpetfish was launched from Portsmouth, a name suggesting speed and predatory grace, a boat that would slide into the Pacific and find very little to hunt. In July, USS Torsk came down at Mare Island, and USS Guitaro at Mare Island as well, and USS Halfbeak from Electric Boat, each one christened with ceremony, with wives and dignitaries and navy bands playing triumphant music, each one assuming its place in a force that was vast and hungry and ready for the campaign that was supposed to come. In August, in the very last days before the surrender, more boats were still being finished, still being readied, their hulls sleek and unknowing. By some counts, more than 50 Tench-class submarines were launched during the war, and many of those came into existence only in these closing weeks, when the enemy was already drifting toward capitulation. The timing created a strange poignancy that permeates the whole class. Here were submarines, remember, designed specifically for a war that required endurance, strength, depth, and staying power. They were meant for patrols lasting weeks and months, for operations far from any support, for the grinding pressure campaign that everyone believed would be necessary before American soldiers set foot on the beaches of Honshu. Every feature of their design, every improvement to their welding, every reinforcement of their hulls and machinery spoke to that coming test. The thicker steel, the redesigned fuel tanks, the quieter engines, all of it was engineered for a war that would be fought in 1946, or perhaps into 1947. No one, even in the final months, could quite imagine that it would end in August, suddenly and with profound finality, in the flash of atomic light and the Emperor's voice on the radio speaking of surrender in a way that very few Japanese had ever heard him speak before. So what happened to boats that had been built for an invasion that was cancelled before their first patrol even began? Some of them, those that were already operational before the surrender, did manage to get to sea during the war's final weeks. USS Torsk, for instance, completed her shakedown cruise just in time to sortie on what would be her only combat patrol, firing at Japanese shipping in the Yellow Sea in those last days of conflict. That boat could at least claim the satisfaction of having done what she was built to do, however briefly. But many others never had that chance. USS Trumpetfish, to name one, was completed and commissioned too late. She made no war patrol. She steamed the Pacific peacetime, as it were, missing the campaign that had consumed her entire design rationale. Picture the men who crewed these boats in those early weeks of service, the submarine sailors who trained and stood watches and lived in the cramped dark spaces, knowing that they had been ready, always ready, to go to war. What must it have felt like to cross the Pacific in a warship that was in every sense prepared for combat, to live according to protocols and schedules designed for danger, and yet to find the enemy no longer firing? There is a peculiar suspension in that condition, neither quite at war nor quite at peace. The emergency bills were still posted, the torpedo tubes were still loaded and carefully maintained. The men still slept in shifts in the narrow bunks, and still ate the compressed meals, and still conducted their drills as though Japanese depth charges might rain down at any moment. But the depth charges never came, the alarms never sounded. The order to dive in anger, the one thing every submarine sailor trained for from his first day, simply never arrived. Some Tench-class boats, by the way, were never actually completed during wartime at all. Their construction continued after the surrender, delayed or slowed as wartime priorities began to give way to peacetime economies. A submarine takes months to build, even with every rivet and weld driven at speed. Some of the class were launched in 1946, or even 1947, coming into the Navy after the shooting had already stopped, stepping into a world where submarines were being reconsidered, where questions were being asked about what they might do in this strange new silence. Those boats have an even stranger history, in a sense. Hulls conceived and designed during total war, finished in the first months of cold peace, intended for an enemy that had surrendered before they could even be crewed and tested. What were they for, these perfect submarines that had missed their war? That question would linger, and the answer would come slowly, reframed by new circumstances, new threats, new oceans waiting in the dark. The war ended on a Tuesday in September, and somewhere in the vast Pacific, the submarines kept moving through the water. A radio man in a radio shack the size of a closet received the news crackling through the speakers, and there was silence on the boat for a long moment. No more targets. No more enemy merchant vessels to hunt. No more Japanese destroyers to run from in the darkness. The Tench-class boats that had been built in such urgent haste, christened with such ceremony, sent to sea with such purpose, suddenly found themselves without that purpose. What happens to a machine built for invasion when the invasion never comes? This is perhaps one of the quieter questions of maritime history, a question that unfolds not in thunder, but in paperwork and reassignment orders, and the slow recalibration of a navy that had to remember how to exist in peacetime. The submarines that had been scattered across the Pacific in wolf packs, hunting in coordinated silence, were recalled to ports that had changed color entirely. Mare Island was no longer a furnace of urgency. Portsmouth Naval Shipyard fell quiet in certain sections. The sense of building for survival had evaporated, and in its place came something less certain, less driven. What would these hulls do now? The first wave of reassignments came almost before the ink dried on the surrender documents. Some Tench-class boats were ordered to remain on patrol, not hunting now but watching, a continuation of presence that had become habit for crews who had known nothing but the hunting war for months or years. These patrols were different in character, though. A submarine running silent above a merchant convoy in 1945 was driven by the knowledge that torpedoes might be the only language that side could speak. A submarine running the same waters in late September or October of that year was simply there, watching, observing a coast that was no longer hostile, a sea that was no longer contested, as if unable quite to believe the change had happened. Other boats were ordered back to the States, to ports where their crews would disembark for the first time in months, stepping onto concrete that didn't move, breathing air that didn't smell of diesel fuel, and human bodies compressed in steel tubes. The process of stood down from war footing is a strangely exhausting one. Imagine the mental and physical recalibration required. A captain who had spent 6 months making decisions that meant life or death for 80 men now had to think about paint schedules and how to keep a crew engaged when there was no enemy hunting them. A sonar operator whose ears had learned to distinguish the specific acoustic signature of a Japanese destroyer had to accept that such knowledge was now historical rather than vital. The decision to mothball began quietly, almost administratively. The Navy had launched hundreds of new submarines during the war, and the post-war budget, while still substantial, could not possibly maintain all of them in active commission. Decisions were made in offices with grey walls by officers who studied utilization rates and crew availability and the projected needs of a navy that had to shrink itself significantly. Some Tench-class boats were hauled into reserve basins, their machinery preserved but not operated, their torpedo tubes plugged, their reactivity removed from the living inventory. This was not disaster for these boats, but it was a kind of suspension, a limbo where a machine built to move was held in stillness. The preservation of submarines in mothballs was itself a technical consideration. You cannot simply walk away from a steel hull that has been operated at depth and under stress. The hull itself, even at rest, requires attention. Corrosion never stops its work. The machinery inside the hull, all the gears and pumps and electrical systems, require specific protocols to prevent deterioration. Officers were assigned, sometimes with minimal crews, simply to keep the boats in such condition that they could be reactivated if needed. These guardian crews had perhaps the quietest posting in all of naval service, boarding their boats in harbours where nothing happened, checking systems that would not run, maintaining readiness for an alert that came less frequently as the months passed into years. And yet other boats of the Tench-class were given new lives almost immediately, though different from anything they had been built to do. The Navy, in its forward-thinking and somewhat anxious way, began to conceive of the post-war world not as a world of peace, but as a world of different kinds of tension. The Soviet Union, which had been an ally in the war against Japan, began almost before the final victory to present itself as a different kind of problem. Submarines, it occurred to many naval planners, were uniquely suited to observing, to listening, to being present in places where a surface ship might be too conspicuous. So some Tench-class boats found themselves assigned to patrol duties in the Pacific, and sometimes beyond, moving through waters not as hunters but as watchers, their crews not looking for targets but for information. These peacetime patrols were strange occupations. A submarine is built for stealth and concealment, and peacetime patrols demanded exactly these qualities, but without the immediate danger that had once justified them. A crew member who had experienced the terrible silence of running from depth charges, the awful knowledge that explosions might come from above at any moment, might find the silence of peacetime patrol almost more oppressive in a different way. There was nothing to fear, and yet the fear remained in muscle memory, in the habits of thought that had kept men alive. The submarine still moved through darkness, but it was a different kind of darkness now. Some boats were deployed to the Atlantic, an Atlantic that had fallen quiet after Germany's surrender, but was now becoming something else, a Cold War ocean. These transits, bringing Tench-class boats to the Atlantic fleet, were often their first voyage of any significance since their construction. For some, the journey itself became their entire known war history, a transit through Panama, across the Atlantic, to Norfolk or other East Coast bases where submarines were being repositioned and reorganized. The crews on these boats sometimes found themselves explaining, again and again, that they had never seen combat, had never been forced to maneuver away from enemy destroyers, had launched no torpedoes. This was not shame exactly, but it was a peculiar form of displacement, a sense of being built for something that had passed them by. The reassignment of Tench-class boats happened gradually, without fanfare, boat by boat over months and years. There was no moment of clear rupture, no announcement that these submarines, designed for an invasion of Japan that never came, would now serve different purposes. Instead, it simply unfolded, the way weather changes, the way seasons shift without anyone quite marking the moment of transition. What had been urgent became routine. What had been rare became ordinary. The Tench-class boats, many of them, found themselves in the strange position of having been built for their own obsolescence, or perhaps more accurately, for a future that never arrived, and then having to invent new reasons for existing in a world that had moved on. The war had ended, but the ocean had not. In the months and years that followed VJ Day, the United States Navy faced a peculiar problem, one that would transform the submarine force from a weapon of hot war into something far stranger, a phantom fleet moving beneath the surface of a new and colder conflict. The boats that had been built for the invasion of Japan now found themselves searching for a different kind of enemy, one that could not be attacked with a torpedo, but only watched, studied, countered with silence and patience. The Tench-class submarines, along with their older cousins in the Gato and Balao families, were still fundamentally sound vessels. Their hulls were strong, their machinery functional, yet by 1946 and into 1947, the question that emerged from naval intelligence and submarine command was not whether these boats should be scrapped, but whether they could be born again. The Soviet Union had begun its own submarine program with increasing urgency. What use, then, were these tired warhorses sitting in the yards? Could they be remade? Could they be quieted, deepened, made fit for the long underwater vigil that would come to define the Cold War? And so there began, in the quiet spaces of the naval shipyards and in the minds of submarine engineers, a program that would come to bear a name both curious and fitting: GUPPI. The acronym stood for Greater Underwater Propulsive Power, though the word itself conjured something gentler, a small, nimble fish, quick and adaptable. The program was born not from a single blueprint or grand decision, but from a gradual realization that the submarines America already owned could be transformed into something the designers of the 1940s had only begun to imagine. The science of it was in many ways counterintuitive. The wartime submarines had been built fast and in great numbers. They sat high in the water, their hull lines above the surface broken by a tall sail, the conning tower that housed the periscope and the radar antenna that created considerable drag. When a submarine moved through water, it was not truly a sea-going vessel in the way surface ships were. It was amphibious, equally compromised whether above or below. The Guppy conversion program asked a radical question. What if a submarine did not need to be amphibious at all? What if it lived in the sea, as a fish lives in the sea, and only surfaced when duty or emergency demanded it? The modifications began with what could be seen from the outside, though most of the work happened in the darkness below. The conning towers were radically reduced, streamlined, shaped to cut through water rather than pierce the air. The hull was faired, given new lines that made the entire boat slip through the ocean with less resistance. Periscopes were repositioned, radar antennas were redesigned and repositioned themselves into that diminished sail structure. What had once looked like a whale with a hump on its back began to look like something truly streamlined, more like a killer whale, sleek and built entirely for motion through an alien medium. But the real transformation, the one that mattered in the depths and in the silence, was what happened inside. The diesel engines that had powered these submarines on the surface were left largely unchanged. You could not easily redesign an engine that had performed adequately. But the way the boat moved, the way it stored and used fuel, the systems that controlled its descent and rise through the water, these changed fundamentally. The battery capacity was increased. The snorkel system, which allowed the diesel engines to run while the boat was submerged just beneath the surface, was improved and refined. More importantly, the Guppy conversions introduced new batteries, larger and more efficient, that would allow a submarine to remain underwater far longer than its World War II predecessors. Consider the paradox of submarine design. In wartime, a submarine needed to travel on the surface or near it for much of its patrol, using diesel engines that were fast and reliable but impossibly noisy. When danger approached, the boat would submerge, running on batteries at a fraction of the speed, deaf and blind to the world above. The Guppy program attempted to reverse this equation. What if the submarine could remain deep, where it was harder to detect, for longer periods? What if the batteries could be improved to the point where a boat might stay submerged for days rather than hours, moving slowly but steadily, a ghost in the depths? The Tench-Class boats, some of them still quite new when the conversions began, became prime candidates for this modernization. The lead boat, USS Tench itself, underwent the transformation. So did many of its sisters. The old wartime submarines were taken into the yards, stripped of their unnecessary fittings, their hulls carefully modified, their interiors reconfigured. It was not simple work. A submarine is a web of interconnected systems, and changing one thing ripples through many others. The shipyard workers, some of them the same men who had built these boats only 5 or 6 years earlier, returned to the vessels they had sweated over in wartime and remade them for a different war altogether. What is remarkable, in a quiet way, is how much of the original Tench design lent itself to these improvements. The welded hull, the carefully arranged fuel and ballast tank system, the relatively modern diesel engines, all of these things meant that the transformation, while labor-intensive, was not impossible. A Gato-class submarine might take longer to modify. A Balao would require more work. But the Tench-class, newer and more intelligently engineered, could become something faster, quieter, more capable, with less fundamental rework. By the early 1950s, the first of these converted boats were slipping back into the Pacific, or heading toward the Atlantic, or taking their places in the Mediterranean, now bearing the mark of this strange metamorphosis. They carried the old names: USS Tench, USS Argonaut, USS Greyback. But they were not quite the same vessels that had prowled the Philippine Sea in 1944. They were faster underwater, they were quieter, they could stay down longer. And they were already, in many ways, the ancestors of the submarine fleet that would characterize the entire Cold War era. The conversion was not instantaneous. There was no single moment when the Navy announced the Guppy program is underway. Rather, it evolved, refined, improved from boat to boat and yard to yard. Some conversions were more thorough than others. Some of the Tench-class boats received the full modernization with new batteries, new snorkels, new hull configuration. Others received partial updates, modifications that improved their capabilities without completely transforming them. And some boats, worn out or deemed less essential, were simply retired from service, mothballed, or eventually scrapped. What the Guppy program represented, fundamentally, was an acknowledgement that the submarine had evolved beyond its wartime role. These were no longer weapons designed to surface, attack, and disappear. They were becoming something closer to what submarines would be for the next 70 years. Platforms for surveillance, for intelligence gathering, for presence beneath the surface where surface ships could not easily follow. The Tench-class submarines, born in the rush to prepare for an invasion that would never come, found themselves instead remade for a different kind of war, one fought in silence and shadow, beneath the thermocline, in the spaces where light does not reach. The sounds of the shipyards changed as the conversions took place. The urgent banging of wartime production gave way to a more methodical, deliberate kind of work. Welders carefully sealed old openings, created new ones. Engineers traced new pathways for cables and piping. The interior spaces of the boats were rearranged, optimized for a new kind of underwater endurance. It was not the frantic energy of a fleet racing against time, but the patient work of transformation. Each modification, a small decision in a larger evolution. And somewhere in those yards, among the welding torches and the steel shavings, among the technical drawings and the careful measurements, the submarine force was changing. The boats were becoming quieter, deeper, stranger. They were beginning their long descent into the Cold War, into an era where being seen at all would be considered a failure, where silence and invisibility would be the highest virtues, where a submarine's entire mission might be accomplished without firing a single weapon, without even being definitively known to be present at all. The Guppy conversions were the bridge between the World War II submarine fleet and the nuclear-powered submarines that would come after. They were the harbingers of a new kind of naval warfare, one that would be conducted almost entirely out of sight. Among the Tench-class boats that slipped into the Cold War, several found themselves threading through waters more treacherous than any Japanese convoy route, not with enemy destroyers overhead, but with something far more abstract and persistent. The immediate post-war years saw these submarines transition from a clearly defined Pacific campaign into a much longer, quieter conflict that would consume decades, asking different questions of both the boats and the men who sailed them. USS Tench herself, the namesake of the class, was among those selected for the extended service life. After the abrupt surrender in August of 1945, she had been at sea for only months, her engines still breaking in, her crew still learning the rhythms of her compartments. Instead of standing down for the victory parades that other vessels received, Tench entered a new phase of existence, not decommissioned, but redirected. The Navy had begun to understand, even before the guns fell silent in the Pacific, that whatever had bound the Allies together against Nazi Germany and Imperial Japan was already fraying. The Soviet Union, whose submarines had proven far less effective during the war, but whose industrial capacity was immense, would soon be the center of strategic concern. For submarines, this shift was almost philosophical. Where they had hunted merchant vessels and warships in daylight and darkness both, They now were asked to listen, to observe, to disappear so completely into the ocean that detection became not just dangerous, but a kind of professional failure. The Tench-class boats, with their improved hull welding and deeper crush depths, were relatively well suited to this new mission, though they were by no means purpose-built for it. That would come later, in the specially designed attack submarines of the 50s and 60s. But the Tenches were available, relatively modern, and their crews were among the Navy's most experienced in submarine operations, so they were kept in service. USS Trout, another of the early Tench-class completions, began operating out of the Pacific Fleet bases by late 1945 and early 1946. The post-war patrols operated under strict new protocols. Boats were assigned to shadowing Soviet ships in the Bering Sea and around the fringes of Soviet Pacific territories. The work was monotonous, in a way that even the longest wartime patrol had not been. A wartime submarine knew, at least, that it was hunting for a defined enemy with a defined purpose. A Cold War patrol submarine knew it was watching, waiting, gathering intelligence, but the enemy was largely invisible, present in policy and ideology, rather than in the form of a destroyer bearing down with depth charges. The crews had to adjust to long stretches of absolute silence and inactivity, punctuated by rare moments when a Soviet vessel would pass through the patrol area and the boat would have to position itself to take photographs and measurements. The physical conditions of these patrols were no gentler than wartime operations had been. A Tench-class boat operating under the Arctic ice, which several of them did by the early 1950s, faced a different kind of peril. The ice above prevented emergency surfacing. If the boat suffered a critical systems failure, there was no possibility of blowing tanks and rising to the surface for repairs. Submarine captains and engineers had to maintain absolute confidence in their machinery and their crew's ability to solve problems in silence and darkness, far below a ceiling of ice, sometimes 20 feet thick. The hum of the diesel engines had given way to the near-silent turning of electric motors, powered by batteries that had to be carefully managed lest they be exhausted with no way to surface and recharge them. USS Greyback, one of the later Tench-class boats to enter service, spent much of the early Cold War period conducting similar patrols, though her primary theater was the Sea of Japan and the waters around the Korean peninsula. When North Korea invaded South Korea in 1950, the submarine command suddenly had a more conventional mission again, or at least one that more clearly resembled wartime operations. Greyback was moved to Korean waters to interdict supply lines and gather intelligence on Soviet and Chinese movements. The boat's deeper diving capability, a legacy of the design improvements that had been incorporated into the class, gave her a significant advantage in these constrained and heavily patrolled waters. The texture of daily life aboard these boats during the early Cold War years was, in many ways, indistinguishable from wartime submarine service. Men worked in 4-hour watch rotations, though the intensity of alertness demanded was different. During a wartime patrol, every sound from above was potentially a threat. A Cold War patrol submarine listened for the same acoustic signatures, but they were not hostile, not yet, anyway. They were data to be collected and catalogued. The crew had to maintain a state of readiness that felt almost abstract, a professional vigilance without an immediate, tangible danger. The galleys of these boats became, if anything, even more important during the Cold War years. The long endurance that had been designed into the Tench-class hulls was useless if it came at the cost of crew morale or physical health. The Navy understood that submarine crews were among the most elite and most carefully selected personnel in the entire service, and their morale had to be maintained through the long weeks at sea. Cooks in the small galley spaces became crucial figures in the social ecosystem of the boat. A well-executed meal, roast beef, mashed potatoes, fresh bread, baked in the tiny oven, could sustain a crew psychologically through weeks of silence and confinement, in a way that emergency rations never could. The silence itself was profound. In wartime, a submarine under depth charge attack had to maintain near total silence, but that silence was temporary, lasting hours at most. A Cold War patrol submarine in certain areas had to maintain near total silence for days or weeks at a stretch. No radios could be used. The machinery had to be operated at the lowest possible noise levels. Men moved through the compartments in a kind of choreographed quiet, aware that a single clanging tool or a carelessly dropped wrench could betray the submarine's position to Soviet hydrophone arrays that were being deployed across the ocean floor with increasing sophistication. USS Tench and her sisters developed a kind of monastic quality during these years. Quiet communities of men living together in the closest possible proximity, bound by the knowledge that their survival depended on their collective expertise and discipline. The Cold War patrols were longer than wartime patrols had been, sometimes extending beyond 90 days, and the boats pushed deeper, staying longer on station, returning less frequently to port. The men who served aboard these boats were volunteers, deeply trained, and many of them made careers of submarine service that spanned the entire Cold War era. By the 1950s, as the Navy began bringing newer, faster, and more capable submarines into service, boats designed from the outset for the Cold War mission, many of the Tench-class boats were gradually reduced in frequency of patrol or finally decommissioned, but some continued operating well into the late 1950s and even beyond, their proven reliability and deep diving capability making them still useful even as they aged. The very design improvements that had made them so advanced in 1944 and 1945 allowed them to remain operational long after their original purpose had passed. The thicker steel of the hull, the improved welding that gave them greater structural integrity, these features meant they could endure the rigors of extended patrol service year after year. The question of what these boats actually discovered during all those patrols, what intelligence they gathered, what strategic value they provided, has largely been consigned to classified archives that may never be fully opened. But the simple fact of their presence, American submarine hulls moving silently through Soviet-monitored waters, observing, listening, ready, was itself a kind of statement. The Cold War was, in its deepest essence, about the projection of power through deterrence, through the threat of response, through the maintenance of strategic balance. The Tench-class submarines, though they never fired a shot in anger during the Cold War, were instruments of that balance, and their patrols, though rarely spoken of in public, were fundamental to the naval strategy that defined the era. Today, several of the surviving Tench-class submarines rest in the soft silence of museum berths, their hulls no longer cutting through dark water, but held fast in place, cradled by the very docks where they were born, or nestled in ports far from the Pacific where they once prowled. The USS Drum, the USS Gato, the USS Silversides, these are not the only Tench-class or sister ship survivors, but they exist now in a different kind of service, one that asks them to hold still, to be read like books, to let human hands trace the grooves and seams that once meant survival at 400 feet below the surface. If you have ever stood on the deck of a preserved submarine, you will know a particular kind of quietness that descends upon you as you enter the hatch. The air inside is cooler than outside, even on warm days, because the sun never reaches far enough into those narrow passages to warm them. The steel hull itself seems to absorb the warmth and hold it apart, and as you move forward through the control room, past the periscope stations and the fire control equipment mounted on walls that have not moved in decades, you begin to sense something of what it meant to live inside this thing while it was alive. The instruments are still there, gauges and switches and speaking tubes, all arranged exactly as they were in 1944 or 1945, all painted in the faded colors of wartime, olive drab and pale yellow, colors that seem impossibly delicate now, almost precious. What strikes visitors most often is the extreme narrowness, the way the submarine seems designed for people smaller than most modern humans. The torpedo tubes are tight cylinders, and the crew's berthing spaces, the bunks stacked in rows where men tried to sleep, despite the hum and vibration of diesel engines, despite the knowledge that a single depth charge from above could collapse the entire structure around them. These spaces are so confined that you must duck your head, must turn your shoulders sideways to pass through. A submarine was not built for comfort or for the luxury of solitude. It was built for function, and its dimensions were the minimum necessary to cram the machinery and the men together in a steel envelope. The creak of the preserved hull is something most visitors do not expect. Steel, even in stillness, continues to move infinitesimally as temperature changes, as moisture in the air shifts, as the weight of the ship settles slightly in its berth. A real submarine at sea would have made constant noise, the rumble of engines, the whistle of air flowing through ventilation systems, the clank of the collision alarm, the hiss of compressed air being blown into the ballast tanks. But here, at rest and powered down, the creaking is almost meditative. It is the sound of time itself, of metal aging gracefully, of something that once was vital learning how to be a monument. The crew's mess, the small gathering space where submarine crews took their meals when they could gather at the same time, which was rarely, preserves on its walls a kind of frozen domestic tableau. There are photographs of hometowns, pencil drawings, perhaps a calendar from 1943 or 1944, still marking days that are now 8 decades past. The galley itself is remarkably small, and yet during the war, the submarine's cooks achieved something close to the miraculous. They produced meals that were so notably better than the food served on surface ships that sailors occasionally volunteered for submarine duty primarily to eat better. In those close quarters, a good meal was one of the few genuine comforts available, one of the few breaks in the monotony and tension of patrol. The galley is silent now, but its presence speaks to a very human need that persisted even in circumstances of extreme danger and confinement. Walk deeper into the submarine, toward the engine room and the stern, and the space becomes almost claustrophobic in ways that the front compartments are not. Here is where the men who kept the submarine moving lived and worked. The machinists' mates, the electricians' mates, the officers who stood their watches in the control room but rotated through the machinery spaces as part of their training and their duties. The diesel engines, which now sit silent and permanently still, were once alive with heat and vibration and the precise, practiced motions of engineers who knew every valve and coupling as intimately as one knows a familiar room in one's own house. The electric motors that powered the submarine when submerged are also here. Immense cylinders that once drew power from the battery banks, batteries so large that they occupied an entire section of the submarine's hull, beneath the crew's berthing spaces, releasing hydrogen gas as they discharged, creating a steady low-level danger that the crew simply accepted as part of the job. Many of the museum submarines preserve not only the physical structures, but also the personal artifacts left behind or donated by crews who served on them. Letters, some of them never sent. Photographs of sweethearts and family members, faces that would have been stared at during lonely watches, during moments when a sailor's mind was allowed to wander from his immediate surroundings to imagined futures that sometimes never arrived. Diaries, when they have survived, offer brief windows into the emotional life of men who were performing dangerous work while projecting outward calm and competence. The interior of a preserved submarine becomes, in this way, a kind of collective memory. a three-dimensional space that holds within it the anxiety and boredom and occasional terror and frequent humor of those who lived and worked within it. Do you know what it is like to stand in the control room of a submarine and imagine it in action? The red lights activated to preserve night vision, the steady stream of reports coming through the sound-powered telephones, the commanding officer staring through the periscope at a distant cargo ship, the torpedo crew standing ready at their stations, the silence that must have been profound in those moments, the complete stillness of the submarine as it glided just beneath the surface, undetected and full of lethal potential. The museum preserves the physical reality of this space, but the imagination must supply the movement, the danger, the lives at stake, and the moral weight of the decisions being made. It is worth noting, perhaps, that many of these museum submarines are themselves Tench-class boats, or ships so close in design and era that the experience of walking through one preserved example gives you a nearly identical sense of what served in another. The USS Gato, which survives as a museum ship in Vallejo, California, is actually a Gato-class submarine, slightly earlier in design than the Tench-class, but the improvements and refinements made in the Tench-class would have been incorporated during wartime modifications, so the line between the classes blurred even during the war itself. A preserved submarine from the early 1940s and one from the late 1940s are not dramatically different in the spaces they offered their crews, though they might differ significantly in their machinery, their speed capabilities, their diving depth, and their endurance. The experience of being inside preserved steel, however, is remarkably consistent. For visitors, the walk through a museum submarine often becomes meditative in an unexpected way. There is something about the confined spaces, the careful restoration of period details, the obvious care with which the ship has been maintained, that creates a kind of communal reverence. Families stand in the control room in quiet conversation. School groups move through in orderly lines, guided by docents who know the specifications and the history, who can tell you the names of the submarine's commanding officers and the names of boats they sank or encountered. The submarine itself, in its preserved state, becomes a kind of text that can be read, a three-dimensional narrative that tells you what it meant to believe in a mission, to trust your crew, to sit in a steel tube beneath thousands of tons of water, and trust that your engineering and your skill and your courage would keep you alive until the mission was complete and you could surface and breathe air again. The creaking continues as temperature shifts, as seasons change, as the submarine ages in place. It is a gentle sound, a reminder that even in stillness, even in preservation, the ship remains somehow alive, holding the memory of its service, inviting new generations to stand where crews once stood, to understand, insofar as understanding is possible in safety and quiet, what it was like to live inside a machine built for war, built for depths where sunlight never reaches, built for a purpose that was always, in the end, about reaching home alive. The steel that formed those hulls, the arrangements of compartments, the weight distribution studies conducted by engineers hunched over their drafting tables in the decades before computers, these decisions did not vanish when the war ended and the last Tench-class boat slipped into peacetime. Instead, they persisted. They lived on in the drawings and in the minds of naval architects who understood, more completely with each completed hull, what a submarine could become. The Tench-class represented a certain maturity in American submarine design, a refinement achieved through the accumulated knowledge of building and deploying more than 150 vessels during the war years. The hull form itself, that distinctive shape you might glimpse in faded photographs, the rounded pressure hull nestled within the outer casing, the tapering toward bow and stern, this geometry would echo through the next generation. When designers at Electric Boat and Portsmouth began sketching the boats that would follow, they did not discard what the Tench engineers had learned. They built upon it. The welded construction that had proven its reliability, the deep diving capability that the reinforced hull had demonstrated, the refined fuel ballast tank arrangement that allowed for longer patrols without refueling, these were not experiments to be forgotten. They became inheritance. They became standard. A submarine built in 1952 would not look fundamentally different from one built in 1943, because the fundamental problems, how to go deep, how to stay silent, how to carry enough fuel and supplies to vanish into the ocean for months, these problems had been solved already, and the solutions could not be improved upon in any radical way. There is something almost meditative in contemplating how form finds its way across generations. The pressure hull diameter, carefully calculated to balance strength against displacement and hydrodynamic drag, would appear again in the Tench-Class submarines completed just after the war. The machinery spaces, rearranged so thoroughly in the Tench design for quieter operation, informed the sound-dampening principles that submarine acousticians would refine throughout the 1950s. The location of the conning tower, the arrangement of periscope wells, the placement of torpedo room equipment, these spatial decisions rippled forward. When the Guppy conversion program took older hulls and transformed them with new snorkel systems, streamlined sails, and improved diesel-electric machinery, the designers working on those retrofits were, in many ways, polishing the basic architecture that Tench-class builders had established. You might say they were not inventing anew so much as clarifying what had always been latent in those hulls. The Tench-class, with its comparatively quieter machinery, was an ideal candidate for these modernizations. Its hull could accept the improvements without fundamental redesign. The conceptual leap toward the truly post-war submarine, the nuclear-powered boats like the USS Nautilus and the Skate class that would follow, these vessels required entirely new thinking, new physics, new metallurgies suited to handling the heat and pressures of atomic reactors. And yet even there, in those revolutionary hulls, traces of the Tench class persisted like echoes. The pressure hull diameter of early nuclear submarines often matched the dimensions established in the diesel-electric era, because the diameters that had proven efficient in the 1940s remained efficient. The torpedo room layout, refined through hundreds of practice loadings aboard conventional boats, carried forward into the age of Polaris and Trident missiles. The crew berths, the galley arrangements, the officers' wardroom dimensions, these human spaces, once optimized for a group of 80 men in a steel tube, did not become obsolete simply because the power plant changed. Naval architects describe submarine design as an endless series of compromises, and in that sense, the Tench class represented a particular moment of balance, a boat that was tough, that could dive deep, that carried enough provisions and fuel for extended patrols, that integrated all the combat systems developed by 1943 into an efficient package. When the question arose later, as it inevitably did, of how to build something faster, something quieter, something that could dive deeper still, the starting point was always the Tench baseline. The designers asked not what entirely new architecture might we imagine, but rather, what did the Tench class do so well that we should preserve it, and where did it fall short that we might improve? This is how technical legacy persists, not through wholesale copying, but through the understanding that precedes copying, the comprehension of what problems the Tench class had solved, and acceptance that those solutions were often elegant and durable. The submarine designers of the 1950s were not reverential toward the Tench design, not in any sentimental way. They were pragmatic. If a hull diameter worked, you kept it. If a torpedo tube arrangement maximized efficiency, you retained it. If the balance of buoyancy and weight had been carefully calculated and tested, you did not lightly alter it. There is a quieting effect in understanding how the past embeds itself so thoroughly in the future, how decisions made by exhausted engineers in wartime shipyards, working under pressure to build as many boats as possible as quickly as possible, would echo through decades of naval construction. They were not designing for history. They were designing to solve the problem in front of them: how to make a submarine that would be better than the last one built, that could go deeper, stay out longer, carry more supplies. They were trying to win a war, and yet in doing so, without knowing it, they were establishing templates and precedents that would outlast any single conflict. When you examine a schematic drawing of a submarine built in the 1960s or 1970s, in the height of the Cold War, comparing it with the plans of a Tench-class boat from the 1940s, the underlying similarities are striking. The pressure hull is still fundamentally a long cylinder. The propulsion remains diesel-electric in the conventional boats. The torpedo tubes still pierce the bow. The periscopes still rise from the sail. The compartments are still arranged fore and aft. The problems of how men sleep, eat, defecate, and maintain their sanity in a sealed metal tube while submerged for extended periods remain the same. And so the solutions, refined but fundamentally similar, persisted. One might ask whether this represents a limitation of submarine design, a failure to imagine radical alternatives. Or perhaps it represents the opposite, an acknowledgement that certain principles once established are nearly optimal within the constraints that submarines must obey. The Tench-class fell somewhere in the middle of its own development arc. It was not the first of anything. It built consciously on Gato and Balao experience. But it was sufficiently refined that what came after, at least in the conventionally powered boats, moved more in the direction of incremental optimization than fundamental reimagining. The influence extended even to the submarines of other nations. British designers studied American boats, including the Tench-class, in planning their own post-war submarine program. Soviet designers, through their own intelligence networks and through the reverse engineering of captured vessels, absorbed lessons that filtered down through American design practice, which had itself absorbed the hard-won knowledge of the Tench-class. In this way, an engineering solution developed in the design rooms and shipyards of 1943 and 1944 became, through the diffusion of naval knowledge, a principle that influenced submarine construction across multiple nations and multiple decades. The creeping distance of years softens our perception of all this. We look back at the Tench-class now as a historical artifact, a relic of a war that ended more than 70 years ago. But the DNA of that design is not locked in museums. It is still encoded in the principles that guide submarine architects today, in the assumptions they make about how a submarine ought to be proportioned, how its systems should be arranged, how much steel needs to separate its crew from the crushing pressures of deep water. The Tench-class did not invent submarine design, but it refined it to a point of such efficiency that its fundamental approaches have never been fully superseded. This is the kind of legacy that rarely receives fanfare or celebration. It is not the story of a dramatic invention or a revolutionary breakthrough. It is the quieter story of how competent engineering, once established, perpetuates itself, how decisions made under pressure and constraint, if they are sound, echo forward into futures their makers could not fully imagine. The Tench-class submarines were not built to be monuments to design excellence. They were built to hunt and patrol, and yet in doing that work well, they established patterns that would be difficult to improve upon, patterns that still shape how submarines are thought about and constructed in the world today. And so the boats themselves, those steel vessels that carried men through crushing depths and into the uncertain promise of a war that would not require them, each found its own path through the years that followed, some swift and others long and wandering, each ending arriving with its own particular quiet. The USS Tench herself, the lead boat from which all the others took their designation, served through the final months of war with measured purpose, and when the surrender came, she was among those selected for the slow work of conversion. She was rebuilt, refitted, given new electronics and new ears to listen with, and for years she moved beneath the surface of oceans no longer crossed by enemy ships, until finally, in the 1970s, she was taken to the breaker's yard in New Jersey, cut apart piece by careful piece, the hull that once dived deeper than the Gatos could manage, returning to scrap metal and the melting furnaces. There is something both inevitable and gentle about such an ending. The steel that served being returned to the possibility of serving again, in new forms, in uses no one could have predicted. Other boats in the class chose different fates, or had them chosen for them. Some were used as targets, which may seem a sad conclusion, but carried its own strange dignity. The USS Flyer, for instance, survived the war intact and served through the post-war years, but eventually she was designated for the SYNC program, the SYNC exercise, wherein aging vessels were towed to designated waters and methodically subjected to live fire and bombing runs, used to gather data on how modern weapons performed against a real target. She was sunk off the coast of Hawaii in the mid-1970s, her hull opened to the ocean at last, not by enemy action, but by the deliberate science of her own navy. There is a kind of melancholy in this, and yet also a purpose. These final moments contributed knowledge that would inform naval doctrine for years to come, a last service rendered by a boat that had already given so much. The USS Thornback was transferred to the Brazilian Navy, where she served under a different flag, bearing a different name, the Tamoyo, and patrolled waters she had never known before, the South Atlantic and the approaches to South American ports. She remained in service for Brazil longer than she served for the United States, which meant that the design philosophy of the Tench-Class, born in American yards and tested in the Pacific, found new purpose in new hands across the world. Eventually she too was broken up, but not before she had carried Brazilian sailors through decades of peace and Cold War vigilance, a kind of second life earned in foreign service. Several other boats were transferred to Allied navies in the post-war years, to the Greeks, to the Italians, to the Dutch. The USS Kittiwake went to Greece as the Delphin, patrolling the Mediterranean and the waters around the Greek islands, while the USS Lapon served the Italian Navy as the Alfredo Capellini, carrying Italian crews beneath the very seas where Italian submarines had hunted in an earlier war. The USS Truta went to the Dutch, becoming the Bahadur, part of the Indonesian naval forces, and sailed waters that Portuguese and Dutch colonizers had once charted. Each of these boats, then, became ambassadors of a sort, carrying American design and American lessons to navies building their own undersea forces, spreading the knowledge that had been won at such cost in the Pacific. Some boats were simply retired to the reserve fleet, mothballed and tied up at naval bases, their crews paid off, their hulls kept in a state of maintained idleness, waiting for a crisis that, in many cases, would never come. They sat in rows at places like Mare Island and Pearl Harbor, their paint slowly weathering, the quiet settling into their empty corridors. To walk through such a boat years after it was decommissioned was to move through a kind of tomb, everything in place as it had been left, the coffee cups still on the tables, the bunks unmade, the engineering spaces dark and still. It is a strange feeling, preserved absence, and sailors who had served on these boats would sometimes return in later years to remember the men they had known, the narrow passages they had moved through in darkness and danger. And then there are the boats that were saved, not for utility but for memory. The USS Bakuna was preserved and eventually placed on permanent display in Philadelphia, her hull open to visitors who walk her passages and try, with some fraction of imagination, to understand what it was to live within such constraints, to know that the steel around you was all that stood between breath and the crushing weight of the ocean. The USS Torsk, another Tench-class boat, was also preserved, and now sits at the Baltimore National Aquarium, where tourists pass through her torpedo rooms and crew's quarters, seeing where the torpedoes were loaded, where men ate and slept and waited. These boats have become classrooms, monuments to a form of warfare that is almost historical now, yet close enough to living memory that the men who served in them are still living, still available to tell their stories to the young people who descend into these preserved hulls. What is curious, when you consider the collective fate of the Tench-class submarines, is the way they were scattered to the winds. Not one end was quite like another. Each boat followed its own arc, some glorious in their later service, some ignominious in their ends, and some, perhaps, allowed a kind of peaceful obsolescence in the reserve yards where they rested. In total, just over 100 Tench-class boats were built or laid down before the end of the war, though not all were completed before the surrender came. Many were simply abandoned on the slips, their construction halted midway through, and these hulls were eventually cut up where they lay, never christened, never having had a crew, existing only as sketches and steel frameworks, before returning to the scrapyards from which their materials had come. The numbers are worth sitting with, if only for a moment. Of those boats that were completed and launched, most saw some degree of wartime service, however brief. Others were launched in the final weeks of the war and never fired a shot in anger, and yet they lived on, serving in the post-war Navy for years or decades. Some served into the 1960s, a few into the 1970s, and the longest-serving Tench-class submarines remained in active use well into the Cold War era, when the nature of submarine warfare had become something entirely different, not the hunt for commerce or the destruction of warships, but the quiet vigilance of nuclear deterrence, the unseen presence maintained beneath the ice and beneath the open waters. The Tench-class boats, designed for a war that ended suddenly, found themselves perfectly suited to the long patient waiting that the post-war world demanded. And in this way, these boats endured, not all of them, not in the same way, but each of them in its own measure, carrying the lessons of one war into the equipment and doctrine of the next, their hulls either broken into scrap or preserved in museums or recycled into foreign navies, their names recorded, their service acknowledged, even if most of the men who sailed them have now passed into the historical record themselves. The USS Tench-class submarines, built for an invasion that never came, ended not in failure but in dispersal. Each boat's fate a small story within the larger story of how nations prepare for wars they hope will not arrive, and what they do with the machines they have built when peace, however fragile, finally settles over the world. In the end, the Tench-class submarines existed in a peculiar historical pocket, built with urgent purpose for a confrontation that never took the shape their designers had imagined. Each hull that slid down the ways at Portsmouth and Electric Boat and Mare Island carried within its steel the weight of strategic assumptions that would shift, then vanish almost overnight. They were born into a war that was already winning itself in the Pacific, even as their construction continued through the spring and summer of 1945. The men who drew their blueprints in 1943 had sketched them for a different future. They had imagined Tench-class boats prowling the waters around Kyushu and Honshu, supporting amphibious forces that would wade ashore under fire, enforcing a blockade that would squeeze the Japanese home islands into surrender through years of grinding attrition. The engineers had seen the depth charges, the destroyers, the defensive waters thick with kamikaze desperation. They had built these submarines stronger, quieter, more enduring precisely because they believed they would need to survive in waters that would fight them with every weapon Japan could muster. Yet in August of 1945, That future simply ceased to exist. The bombs fell on Hiroshima and Nagasaki. The Emperor spoke on the radio. Surrender documents were signed aboard the USS Missouri in Tokyo Bay. And suddenly the submarines that had been finishing their final fittings out and preparing for their war patrols found themselves inheriting a peace instead. What does it mean, one might wonder in the gathering dark, to build a machine for a war that ends before the machine is truly tested? Some of the Tench-class boats saw combat. USS Tench herself got to sea in time to conduct patrols off Japan itself, though by then the enemy was already collapsing. A handful of her sisters made their first runs under wartime orders, but dozens, many dozens, were completed after the surrender or in those ambiguous final weeks when no one quite knew whether the war was ending or beginning again. They had been forged in shipyards where riveters and welders had worked with the assumption that every hull had to be perfect, every weld sound, every system redundant, because lives depended on it. And that care was real, that intention was real, but the purpose it was meant to serve had evaporated. There is something haunting, perhaps, in the very completeness of their preparation. The engineers had solved the problems that had plagued earlier classes. The torpedoes worked now, or worked better, at least. The machinery spaces were quieter. The hulls could dive deeper, stay down longer, venture farther into enemy waters than any submarine America had sent to sea before. All that accumulated learning, all that refinement, all that incremental improvement, born from hard experience in actual combat, it was ready, it was waiting. And then there was nothing left to do with it, except to sail these new boats on training runs, or to prepare them for roles that hadn't even been imagined yet. In those first months after VJ Day, the submarine force underwent a profound kind of disorientation. The boats that had been humanity's sharks in the Pacific, the wolves that operated with a hunter's constant hunger, suddenly had to find new reasons to exist. Some of the Tench class were assigned to training duties, becoming floating classrooms for officers and men learning the new post-war submarine service. Others were placed into reserve, their engines shut down, their compartments sealed and preserved in dry dock or quiet anchorages, like sleeping giants who might one day be needed but could rest now. Still others would soon be called to service again, as the world shifted beneath the surface and the Cold War emerged from the ashes of the old conflict, like something ancient rising from the sea floor. But pause for a moment on those boats that never fired a shot in anger. They carried within their pressure hulls all the intentions of a war council that had believed it was planning for years more of grinding, brutal struggle. Tench herself, the lead boat of the class, would have been, if the war had continued, a formidable weapon in the hands of her commanding officer. Her crew had trained for patrols that might last weeks, hunting everything that moved on the surface and beneath it, enduring counterattack, managing silence and patience in darkness that had never known sunlight. They had prepared for all of it, and then it ended. There is a strange kind of mercy in that, perhaps. The men who crewed these submarines did not have to discover whether the theory was sound, whether the engineers' estimates held true under fire, whether the improved steel really did hold the depths as promised. They were spared that test. The war ended before the Tench class had to prove themselves against a desperate and cornered enemy equipped with acoustic homing torpedoes and new submarine hunting tactics born from years of painful learning. And yet one can imagine, as the listener drifts now in the darkness, in a submarine of their own making, what it must have been like for those crews. To train intensely, completely, with absolute commitment, to know that history was being made around you, that your shipmates on other boats were engaged in the greatest naval campaign the Pacific had yet seen, to understand that your boat, your hull, had been constructed specifically to answer a need that was urgent and real, and then to have that need simply vanish, to watch the war end, to understand that all that preparation, all that sacrifice in time and training, and the hardship of submarine work had been for a future that would never arrive. The Tench-Class submarines did not become relics immediately. Many of them served through the Cold War with distinction and honor, their hulls adapted to new purposes, their systems modernized, sent to prowl beneath the Arctic ice, or to listen in the deep ocean to the sounds of potential enemies they would never engage. They found new meaning, new missions, new reasons to exist. In a way, their story continued beyond the war they had been built to fight. But they carried always that peculiar historical weight, the knowledge that they had been engineered for an invasion that never came, designed for years of bitter struggle that ended before they could be truly tested. Perhaps that is the submarine's condition, in some sense. They are machines built for possibilities that may never arrive. They are systems of extraordinary complexity and sophistication, designed to confront threats that might exist or might not. The Tench-class were simply more aware of this than most, because their intended purpose had been so clear, and its ending so abrupt and total. In the museum ships that preserve their legacy, the hulls that were not scrapped, that were not sunk as targets in some post-war test, that were not transferred to Allied navies, or allowed to rust in forgotten harbors, visitors walk through their passageways today. They feel the narrowness of the corridors. They imagine the crew of 50 or 80 men living and working in those tight spaces, in darkness punctuated by red-lit battle stations. They see the torpedo tubes, the periscope, the attack center with its equipment, and they try to understand what it might have meant to serve aboard such a craft, to have trained for war in its compartments, to have believed that this machine mattered to the outcome of history itself. The steel is still strong. The welds that the Portsmouth and Mare Island workers laid down in 1944 and 1945 are still sound.